All right, folks, we are live again for another Pangburn open mic. I love today's topic, the wonders of physics. And it's kind of coincidence or something that we are tackling this topic this week, because tomorrow, those of you who have subscribed, those of you who have become a Pangburn website subscriber, an official Pangburn subscriber, get to take part in the Q&A with none other than Lawrence Krauss tomorrow. I'm very excited for this. I have my question ready for Lawrence. Regarding physics, I'm going to ask him a physics question related to his new book, The Physics of Climate Change. It's going to be very exciting sitting down with Lawrence and all of our subscribers to engage in the Q&A. If you want to engage in this Q&A, all you have to do is go to pang-burn.com/subscription and become a Pangburn website subscriber. And you'll get to engage in these monthly Q&As with famous intellectuals and authors from around the world. Our December guest is Tarek Fattah, Canadian Marxist journalist, very polarizing on Twitter. Check him out. That's Tarek Fattah, Tarek Fattah. I think it's AH. We've posted about him, so if you want more information, just go to our website, pang-burn.com. You'll see him on our Q&A image. Well, do I have any more housekeeping? Do I have any more Sam Harris housekeeping? No, I don't. So I'm I think Deniability is our official moderator today. I'll hand it over to Deniability. I'll definitely want to chime in at some point today. I have a few things to do, but Deniability, the room is yours.
Hello, welcome all. I apologize, I am insufficiently prepared on the topic of physics, but I am going to try my best to keep it above the belt, as it were.
Yeah, I'll hang out for a bit too.
So, Jack, I know you talk a lot in the physics chat. What do you want to bring up about the wonders of physics?
Oh man, you're putting me on the spot. Well, it is definitely a fascinating topic to me. I am amazed with the understanding of the world that we have today. I think we have come so far. But the problem is that I'm not a physicist. I don't have too much knowledge in the matter, and the fact that I am not a native speaker, I think it could be a barrier. So I'll try to stay back and listen to you guys if that's possible.
Well, let me ask you this: what do you think about and this could be a naive perspective, but when I look at the sciences, I see that there's a lot of disagreement across the board in all subjects. But I would say arguably more so in physics, because it seems like the sort of questions physicists are trying to answer now are so big and require such a huge investment that a lot of the interesting stuff sort of remains in the realm of theory, as it were. Would you agree with that?
So important and potentially life changing on our current understanding of the world and nature, that I believe those are big important questions, and I'm excited, and I hope I can live to the day that we have an answer for those kind of questions. So yeah, that's why it's fascinating to me.
So Tao too, I imagine Taoism would disagree with that perspective Jack just put across.
I think I missed it. I'm just starting my lunch right now, so I'm kind of just starting.
So he was mentioning how he's excited about all the sort of big theoretical questions in physics, like a unifying theory and all that jazz, understanding the Big Bang. He said that it'll provide a fundamental change to our understanding, which I do agree with, but Wouldn't Taoism say something different to that?
That we wouldn't find a fundamental change in our understanding of the universe, because I think Taoism says things are the way they are pretty much, and so new physics discoveries wouldn't really, I don't think would move Taoism
Hey,
anywhere.
bud. You're not getting any sound on the stream.
On the Twitch stream.
No, but the YouTube stream.
Yeah, I know. It's all
Oh, okay.
it's all put on there. Like it's all. I've notified everyone in the chat of what's going on.
Gotcha.
Yeah.
My bad.
Yeah, but Hypnotoad, wonders of physics. Now that you're here,
Huh. What was your question?
The wonders of physics. What strikes you about the physical sciences?
Oh well. The I don't know. I just guess how everything seems to come together in the way that it does, rather than some other way. Things work. I don't know. That's a difficult question. I've not thought about it too much.
I'll have to think about it.
I don't have too good of an answer for it, at least right this minute. But I mean, I have thought about it. But you know,
Don't worry. I'm sure something, just to trigger Mother if she's listening. I'm sure you'll divine an answer through the course of the discourse. But yeah, Dao too. So the Taoist perspective, from what I understand, is all understanding and meaning comes from within. And if you don't understand something, it's because you're not looking deep enough within. And how do you feel that contradicts with the view of physics about exploring the universe and understanding its marvels through demonstration as opposed to reflection?
So I think, since I don't think I'm a true Taoist, because I don't really share the perspective that all knowledge comes from within. I would say something a little bit different, like the conclusions you draw from the knowledge come within. But I from my readings of like the Tao Te Ching and Lietze and Zhangse, I kind of came to the conclusion that Taoism worships the Tao, and it kind of it would equate the ultimate Tao, the ultimate way, with the universe in my mind. But that might just be my. I assume that's my faulty interpretation. I've never had like a Taoist teacher or anything like that.
That's fair enough. I actually wonder if there are any Taoist teachers left. But Sunflower, welcome to the chat. What are your thoughts on physics?
Yeah, basically, I personally believe this is my opinion, but I do believe that all people who deliberately label themselves as an atheist, as some sort of noteworthy or significant part of their identity, are suffering from some sort of mental illness or mental retardation. That's just my take.
Okay, but hold on. Let's take a couple steps back there. So, how does that relate to physics? And you're going to have to substantiate that claim.
Right. So physics all does come down to, I mean, in the atheist worldview, physics all comes down to just, neurons firing. Essentially physics, all brain chemistry and behavior and consciousness is just physics. And there's a certain conformation of neurons and brain tissue that if it's in, it has to be in a certain conformation, which I would diagnose as, deficient or diseased.
Conformation? What is that?
Right. So what that is like the sort of combination, the configuration, if you will. Maybe that's a better word. But there's a prerequisite that you have to have your brain in before you can say I'm an atheist, as if that's some kind of like noteworthy identity label.
Why did you go to atheism? What does that have to do with the wonders of physics?
Yeah, that's what I was asking you to clarify on. Like, how is this related?
Well, it's unique because in the world of physics, it's on the micro and macro scale. There's interesting stuff. And so the brain is, not only a chemical. There's not only chemical interactions, but there's physical interactions, right? And I think it's interesting that on the micro scale, you can it's like a litmus test for like retardation if someone labels themselves as an atheist, and that's like a physical. That's because of the way neurons and other particles.
Sunflower, you're gonna get fucking kicked if you're trolling here.
It's not. How is it trolling?
What does mental retardation have to do with atheism?
Well, physics, so people talk about brain chemistry, but really it's just brain physics on the if you really zoom in, right?
Yeah, chemistry and physics would be well, chemistry is a part of physics.
Right, well, it's just, it's like applied physics.
You could say that.
So sometimes you're going around in circles here. You made 3 claims. You made claims that people who self-identify as atheists are retarded, and then you somehow link that to physics, which I'm still unclear of. And the third one was that actually your point's so confusing. I've lost the third one, but I'm trying to understand how you get from people that are atheists to believing in physics to mental retardation. Like it seems to me to be all over the place.
Okay,
Sunflower, is Lawrence Krauss retarded?
Actually, I think yes.
And why do you believe that?
You can actually make observations on his face, on his facial structure. Like if you look at his face and the way
definitely trolling.
No, like look at the way he like.
Yeah, he's banned.
You gotta be trolled.
Yeah, gotta be trolled.
He's banned. That's.
I think I did a good job of really beating his bad ideas with questions.
Yeah, I think it's just if it just goes like nonsensical like that, then it's just done.
Yeah. That's not something you want to live stream. That would be something you want to talk to him in private about.
Yeah, I mean, I'm fine. Like guys, I'm fine with any ideas. That's why I wanted to hear what his justification was. And then when you start talking about facial structure of a retard,
specifically a person who doesn't happen to be mentally disabled in any way,
right? And this falls under the rule in our Discord of defamation. So.
Ain't nobody got time for that.
Just on the note of people that have mental difficulties, I must say, Travis, your race equation has been very personally enlightening to me. It's dispelled a lot of ill-found preconceived notions about Down syndrome people.
Oh, Reese. The Reese equation. I didn't quite hear what you said there. Yeah. I am like. I've been getting a lot of feedback, actually. Some new subscribers, new people that have come to Pangburn because of them seeing a Reese equation episode. And if you guys have a chance, just take a look at those, because Reese is one of these interesting cases of someone who has just a little dash of Down syndrome. He doesn't have it kind of gives you a demonstration of how wide the Down syndrome spectrum is. So just like, I mean, boxing Down syndrome people in general or retarded people in general into these, definitive boxes is a mistake.
Yeah, I'll face up. I was doing that, and watching the race equation has really enlightened me.
Cool.
So highly recommended if anyone hasn't checked it out.
I'm gonna deke out for a bit. But...
Yeah, back to physics. Welcome, Desired. Welcome, Martin. Opening thoughts on the wonders of physics, Desired.
I think I'll sit this one out as a starting thought and maybe break in. I've got many thoughts that I don't think need to be expressed yet. I'd rather hear some other opinions first.
Okay, Martin, welcome to the chat. What are your thoughts?
Yeah, thanks. Yeah, I thought I just wanted to come and check in and see what you guys were talking about. But although I can, talk a bit of, what I know and what I do, but it's not of like physics and related to like life sciences, which is pretty cool. Especially like in the last 3 years, there's been pretty cool stuff happening.
Yeah,
but
enlighten us.
I don't know, like some cool stuff that I was so I'm doing molecular biology, right? And some very cool stuff that we do now. It's with physics and also computational biology, but like you can pretty much see single cloud electrons with like fancy electron microscopy and good computational averaging methods, which 5 years ago was crazy. Like 5 years ago, you would see like proteins just as like pretty like blurred blobs, and now you can see like like I said, single cloud electrons, which is pretty crazy.
And is this something you do professionally?
So like I'm doing a master's now in molecular biology, but I do study this closely. I haven't done electron microscopy myself, but I do other microscopy.
So I've got a question for you, since you've confirmed that you're sort of into it more so than most. I watched a movie a while back called, I think it was called What the Bleep Do You Know? And they had it was like I hesitate to call it a documentary because it was quite entertaining. But they had a section on where this Japanese scientist had used an electron microscope to take pictures of the structure of water molecules. Of water molecules.
Uh-huh.
And the claim that was being made, that I lacked the sufficient information to investigate, was that the shape of these water molecules was changing based on the environment or the quote unquote thoughts that were being put into them. So he took like water that was blessed by a Zen Buddhist monk, and it had a certain structure. And then he had water where someone had been screaming and shouting at it all day, and it had a different structure. And he was trying to make the case that emotions and thoughts could change the structure of water molecules.
That reminds me of the whole plant thing. Very similar to that. You play like nice classical music to it, and it grows better. But if you play like death metal or whatever, and it doesn't tend to grow as well. At least that's what people say.
I mean, I study like what I've studied about electron microscopy is pretty much with proteins, which are pretty massive molecules, like compared to just water molecules. But yeah, I've heard this before, and I mean, first of all, you would need more than just electron microscopy to defend that claim, and second of all, I think it was pretty clear that, like, I haven't I don't know enough about this specific case, but yeah, I don't think this is true at all. Like it's pretty clear.
I understand.
It doesn't
it's been debunked.
What has been debunked?
The thoughts can affect the way water freezes in a different room.
I mean, to be honest, like water can achieve pretty like unique conformations, because it's like a pretty crazy like structure, because it's like dipolar and everything. But yeah, no, emotions are not part of that.
It's really fascinating to look at, speaking of biology and microscopes, is neurons. Earlier today, I believe I watched a short video of what was a neuron dying, I believe. Somehow it was, I don't know how exactly they went about capturing the footage or whatever, but that's pretty insane to me. Just to be able to see something that, small and
man.
fragile.
Like, something cool about neurons is like, I mean, now, because biology is such a like wide field, physics per se like it was not really like studied as a field of biology, but like some cool things as like quantum mechanics and shit, like starting to get into biology, and like things like quantum tunneling and like electron jumping from neuron to neuron, even though there was actually no connection. All this like is pretty cool stuff.
Yeah, I was actually watching a video on that last night in preparation. I checked out, it was on quantum biology, and they're specifically talking about photosynthesis and how they've discovered that the chlorophyll acts is like the best example of quantum transference, I think it is, where a photon hits the leaf and it goes to the place that generates the food for the, and this is a really bad summary, generates the food for the plants with almost no energy loss whatsoever.
Yeah, exactly. This was one of the examples that I did remember. Yeah, when it goes to the photosynthesis organelle. Yeah, that's exactly the example. Yeah, this is pretty cool. And there's actually, like, in my university in Scotland, that there's some attempts to like start teaching, quantum physics and like quantum biology and some pretty deep physics concepts in biology, because it's actually quite, once you get deep enough into biochemistry and all this, it's quite important, like to simulate or predict protein conformations and all this, because that's still quite difficult.
So let me ask you this: does quantum physics really disprove determinism, or is that a red herring?
Maybe Pangburn would like to jump in, but I do think so. Actually,
I'm a compatibilist that says that physics can only predict so far into the future, so you only have X number of days, years, months, whatever it is, but it's not an infinite determinism, and that can be swapped over by the spooky action at a distance and things like that into the I'm going to use the word chaos, but I mean pure random is what free will is.
Yeah.
Just on a much larger scale.
Can you guys hear me?
Yes.
Yes.
If one is to demonstrate any level of free will, which is what you're talking about when you're talking about compatibilism, it's just kind of framed in a different way. You need to show how anything can obstruct the causal chain of physics. And so far, even in the quantum realm, everything is moving and operating in the way that is determined by the laws of physics. So
sorry, keep going.
So go ahead, Martin.
No, I was just gonna say, like, I mean, not up to like 100%. Like, when you go down enough to like single molecule atoms, like, then you get it might do this 70% here, but then the chances that it does 30 or 30%.
That's a common misinterpretation of what it's not 30%, 70%. That is based on our predictability of equations that we currently have right now. But no physicist worth his snot is ever going to claim that this is the best predictability equation that we will be able to come up with. It's just currently what we are able to compute and predict right now. So
that doesn't mean that you should throw it out.
No, I'm not saying throw it out.
It is natural unpredictability.
And you don't even need to go to quantum physics.
There, and that's why we can't understand it and we can't pin it down, right?
Say that again. Desired, you're breaking up a lot.
Oh, okay, never mind then. I think I'm going through a bad area. Don't worry about me.
Okay.
Like, I was gonna say, you don't even need to get to like quantum effects and quantum physics. I'm sure you know about the n-body problem or the third body problem, when you try to simulate a very, very simple like system of 3 dots. If you go like far enough into the future, like hundreds of millions of years, it becomes impossible to predict.
No, wrong.
Fully what happens.
Martin, that proposition is just we can't make that positive claim that it is impossible to predict. We can't make that claim and demonstrate.
Sorry, with current methods.
Yes, sure. and you just outlined it. You just outlined where people get stuck trying to demonstrate some level of free will or compatibilism. People end up getting boiled down to, based on our current understanding, it seems impossible X. That is not an argument evidence positive for free will or compatibilism. You have to find, and people are always bouncing around looking in the wrong areas. You have to find and demonstrate where something interrupts the determined causal link that the laws of physics allows. And people like Sam Harris and have looked, and other philosophers have looked, and other scientists have looked. They've looked for these things to where they can demonstrate this happening, and it just has not been demonstrated.
I just wanted to say that just because I was saying that, there is some weird things that we with our current methods cannot fully predict right now, I was not making a case for free will in the sense that we humans can choose what we want
right
to do.
No, I understand. I mean free will of anything, not human beings. Free people present this idea of free will of the quantum mechanics, man, and it's not free will of anything. Talk to any any particle physicist who has studied this. They will say this is what we seem to be observing with regards to this, but we just don't know what is going on. That's essentially the basics of what we understand about particle physics and quantum physics. We have some equations that are interesting and give us some predictability, but it doesn't mean that anything is by default random because we don't have the equations yet.
Okay, yeah, sure, but we do also, sorry, I just wanted to make the case that we do have experimental evidence of for example quantum tunneling or the things that up to it's very rare, but it does happen.
Yeah,
that's
so
for example why you cannot make very small microchips and all this.
Yeah, so quantum tunneling, Martin, this is just a demonstration of some things that exist within the laws of physics. It's not a demonstration of anything breaking up that causal chain.
Sure. Yeah.
Yeah. So I think language is important, and this is where philosophy, when I think theoretical physicists are actually the true discovery philosophers of our time when they think about these things, and they think about the language in the scientific communicator types, the Brian Greens, the Lawrence Krauses, the way that they have to come to explain these things and attempt to try. I think Lawrence Krauss made a big fucking error of confusion by calling pre-Big Bang states nothing. It's a poor use of language, and I like and my coined term is state of potential, and then I think we have to be very, very humble when looking at these and we've already talked about the kind of the shaky realms of science where it seems that the demonstrability of some of these physics equations, especially the equations of the very, very small, it seems to be hard to create demonstrations, but the equations, we know based on the math, based on the equations, that they're there. It's just hard to create demonstrations of what's there. So it really is, it's not, it's frustrating. It's not like the hard science of biology, where you can essentially create mixtures, measure bones, and all kinds of stuff like that. Like you have this tangible evidence outside of mathematical predictability.
I suppose it's the whole gas equation problem without a reasonable way to theorize the ideal. Because in the way that all our equations around gas are based off of the false construct of an ideal gas, but that's presumably because we could figure out what an ideal gas would be and then create equations off the back of that. Whereas I guess with quantum physics, our understanding is so poor that it's difficult to come up with that ideal to verify our equations against.
Yeah, it's
what do you guys think of
go ahead.
Sean Carroll?
Can I present a thought experiment?
Wait, hold on. Let's go Daotsu first, and then decide you can present.
So Sean Carroll, I think, my understanding, would disagree with Travis and my intuition, which, because I kind of agree with Travis, But I think Sean Carroll would say something like the wave function is real, and there's nothing underneath it that's determining it. That's the real part of reality.
Wait, say that again.
Wondering,
the wave function?
The wave function. There's another word that he uses that I can't remember right now that basically means the space of all possibility.
Oh yeah. That all falls within the realm of physical reality, within the realm of the laws of physics. So he's not saying anything outside of the realm of the laws of physics.
I think he's arguing against determinism.
Yeah, it's not. It's a. If he is, it's a common mistake. It's not. People need to stop trying to argue against determinism and try to demonstrate the proposition of free will. You can't just accept it and then.
What do you mean by that? Why can't you just do the math and see what it comes out to? Because that seems out. Every time I've seen Sean Carroll presented, it seems like he came at it from, I followed it and this is where it landed. Not, I tried to attack determinism or I tried to attack free will.
So
that's the opposite of how science is, isn't it? We just do the math and whatever it says and whatever it tells us, that's the answer.
But you always start with a thought, with a, how do you say this?
Yes, and you're supposed to start from the position of a position of evidence. So what is evident and what is it? Let's go in and discover it.
Well,
let's make a hypothesis about it.
Can I propose my thought experiment and see if that helps me understand kind of what you're saying?
Sure.
If we could take a box that's X size, I don't care about the size, right? And in some way divide it from time to where it's a standalone thing, a standalone whatever. And I can control whether that every bit of thing that is in that box, I can control whether it changes its state or not. Yes.
But to just go back there, you cut out at the point where you said, and I can take this box and
fill it with whatever particles, but I can control those particles. And I can choose when they change and when they don't. Okay? If no change whatsoever is happening to any particle inside this box, is time happening in that box?
This is why
no electrons are touching each other. Yeah. No, nothing. So, all electrons are frozen in place. All anything.
Yeah, this is why I talk about time with regards to macro time and micro time. On a micro time scale, no, there is no. But on a on a micro time scale, no. But on a macro time scale, the time scale of everything that has ever been ever, not.
That's bringing in more than my thought experiment. I'm talking about solely in the box. Does time exist?
The question is in your frame of reference. No, there is no change. You cannot tell time in your frame of reference.
If you're doing that, right, every change of any one particular, whatever size you want to make it in there, generate a time calculation. That is when time
coming out big time.
When there is a change.
Sorry, did you say that any change, even if it's very small, is like a time calculation? Sorry, what do you?
That is what generates time happening. There must be a change to something inside that box for time to cross to be had.
But
those particles will still be in the box, right?
Yeah, so this is why I talk about the state of potential desired, because there is the two times I'm talking about is important in this proposition.
Travis, before
what I think is that you're
desired. Just wait until you get a better connection here.
Yeah.
I have a question before we move on. Can you, Travis, give us a brief summary of what you mean with free will and determinism for those that are not familiar with the terms?
I mean, we don't necessarily have to we talk about free will and determinism too much on the air. I would rather not talk about that today and focus on like just aspects of physics that we don't normally discuss. But I'll leave that up to deniability to maneuver.
Sorry,
Yeah,
could I ask
was
something?
about to put it up into the. I'm sorry for bringing it up, but yeah, I was going to bring it up into it after Desired's hypothetical
Okay,
there.
no
I would
problem.
just like to say one more thing to ask some more thing to Travis if I could, but we can change topics if it's
Yeah, we're going to change topics now.
okay.
But don't worry.
Martin,
determinism comes up a lot.
yeah,
I'm sure
you
we'll
guys,
have
just
that one.
just FYI, guys, if you do become a website subscriber, you do get a one-on-one with me, taped and recorded, if you wish, monthly. So do consider, if you do find value in that, and of course you do get to attend the Q&As with people like Lawrence Krauss, Tarek Fattah, Brian Green, and different people that we will have on the Q&A. So pang-burn.com/subscription. Sorry, deniability.
Cool. Oh, yeah, Grim, welcome to the chat. We are moving on to new topics, so I'm putting the onus on you to break us into something on physics. Mr. Grim? Earth to Mr. Grim? No. Okay. No takers. Okay, so physics. Maybe Martin can answer this, but we talked a little earlier about how physics, and specifically theoretical physics, is probably the most hotly disputed subject on the planet. Would anyone like to set up the various unifying theories or lack thereof, so that we can get into some discussion there?
Like, do you mean about like we have theories for the macro, we have theories for the quantum frame of reference over the very small, but we don't really seem to have a way of unifying them both.
Correct.
Right?
Micro and
Yes.
macro.
Yeah, I mean micro is way. I mean, if you get picky about the terminology, it's way too big for quantum. But yeah, the quantum world, and then very massive things like black holes, like very big gravitational fields and all this.
Man, I just have to say I am addicted to the movie Interstellar for a few
me
different
too.
reasons. But I really, it's such an inspiring film for me, especially the time differentials that occur.
Yeah, right.
That part of that film is
That's
the
the
most
best.
exciting part to me as a viewer. Just the time
Right.
differentials when they're you've jumped in a wormhole, you've traveled just outside a black hole, and you find these new viable planets for human beings, and while you're down in some of these planets, all this time is going by in just a matter of minutes. It's very inspiring.
Man, I hope you don't know the book I'm gonna tell you, because if you don't, I'm probably gonna make your day happy as hell. Because do you know the book by Kip Thorne, The Science of Interstellar?
Oh, I mean, I don't know. I've heard a lot of discussions about the book, but I haven't read the book. But
Man, like I got it, and it's pretty amazing.
is it? Yeah.
You would love it. Yeah. Like you have things like he also talks about the science behind the tidal waves. When they go to this planet where there's like full of water.
Yeah.
And all these waves, and that's actually created by, the black hole
Right.
pulling from one
Isn't
side
that
of the planet
crazy?
more than the other.
Yeah.
Yeah.
And Neil deGrasse Tyson actually did some videos after. Even though I'm not a huge fan of his communication style, but he did some stuff after as well. A few science communicators did. I think Lawrence Krauss did as well. I'll have to look at that, but perhaps some interstellar questions would be interesting for Lawrence tomorrow. But fuck yeah, that is an inspiring movie. The idea of a black hole, that's why I got it tattooed on my left arm in the middle of my cosmos that I have on my left arm. It's just a perplexing thing that, like, even listening to Stephen Hawking talk about it for so long, write about it, and not knowing much. Like, we know, it's like, I don't know. I'm always at a loss of words when I even think, like, where my mind goes when I think of black hole is to basically just avoid state of potential. And that's kind of what I'm building my unifying theory around, is that state of potential, and
they're pretty cool. Yeah, it's another kind of place where like physics cannot really say at all what's going on inside. Some pretty cool stuff happens in mathematics, like for example, like maybe some people know about this, but like one of the ways that they explain how it's impossible to get out of a black hole, of the event horizon, is that when once you cross the event horizon, actually traveling back, what you would say like going out, it's actually the same as traveling back in time. Like what I'm trying to say is that for you to go back out of the black hole would be the same mathematically as traveling back in time. That's that's why it's impossible to go back out, which is crazy.
Yeah, so just a little bit, I just want to read a little bit of information here. What do black holes look like? Black holes have 3, quote, layers: the outer and inner event horizon, and the singularity. The event horizon, what the hell is this? I don't want to subscribe. The event horizon of a black hole is the boundary around the mouth of the black hole, past which light cannot escape. Once a particle crosses the event horizon, it cannot leave. These are bold physics claims. Gravity is constant across the event horizon. Those 2 sentences alone are enough to fill up my scientific inspiration meters for the rest of my life. I have to read.
What do you mean by gravity?
I have to
constant across. Sorry.
So once a particle crosses the event horizon, it cannot leave. This is stuff written by Stephen Hawking, and we can investigate this further if we wish. And then also the final sentence: gravity is constant across the event horizon.
Like in a way that is the same right out and right in, or like at the level of the event horizon, like
so across the event horizon.
Okay.
I think these sentences are so brilliant because even though are big claims, they are so simple to understand.
Right. So and this is what my theory is based around, this unifying theory. It is fucking dead simple. So the event, and just to be clear, the event horizon of a black hole is linked to the object's escape velocity, the speed that one would need to exceed to escape the black hole's gravitational pull. The closer, here's a bit more information. The closer someone came to a black hole, the greater the speed they would need to escape that massive gravity. The event horizon is the threshold around the black hole where the escape velocity surpasses the speed of light.
Yep.
According to Einstein's theory of special relativity, nothing can travel faster through space than the speed of light. This means a black hole's event horizon is essentially the point from which nothing can return. The name refers to the impossibility of witnessing any event taking place inside that border, the horizon beyond which one cannot see. So that is a frustrating aspect of an observational type species like us that wants to see things.
I was going to say we're primitive, so to understand it is hard. But I look at a black hole as not something that has any effect of speed, but almost of warping, right? So light won't escape it, but neither will anything else because it warps. So if we did have something stronger than light, could it or could not still escape? Not escape the event.
Yeah, well, that was
it's being warped.
That particular segment was talking about just the velocity and speed elements.
Oh my.
Yeah.
So that's something that's always confused me about this speed of light and not being able to surpass it. So maybe you guys could answer it. But I've had a look at the various propulsion technologies we're developing for space exploration, and one of them was the solar sail thing that it catches photons that it doesn't like absorb it in the sense of like a solar panel, but it uses the slight push of the photons to propel you forward. Now it's a very slow sort of technology, but the point they're making is that in the vacuum of space, because you've got no friction, that you're just constantly building on that speed. So just going off that, why does it get to the point where you can't travel faster than the speed of light?
So it's a weight problem. And just the basic answer to that is, okay, here's a paragraph. As objects travel faster and faster, they get heavier and heavier. The heavier they get, the harder it is to achieve acceleration. So you never get to the speed of light. A photon actually has no mass. So you have to get something less than no mass.
But I mean, okay, so something example are to just, let's say for argument's sake, you had enough rocket fuel to push you for however long to approach the speed of light. Why would weight factor in the vacuum of space?
Here's a more comprehensive.
But you just said something that's also incredibly fascinating to wrap your head around. Like you literally, and you can study with particles. You literally get heavier. Particles literally get heavier the faster they go.
Right, exactly. That's the point.
Which is insane.
Yeah, and the thing about photons is they have no mass, so you have to be traveling massless to match the speed of light.
I see.
Yeah.
Okay.
Also, I just shared a URL of some recent news about some papers in physics that came out recently, and I never came out. I always left it here without reading. But it's basically about how this never resolved paradox in physics. They claim that they have resolved it somehow. How if particles are always falling in the black hole, we also know that, for example, black holes do evaporate, like this Hawking radiation things that Stephen Hawking.
Before we march on here, just because there's a couple of people watching, maybe you could just set up the information paradox for us.
Yeah, I was trying to read this to be able to define it a bit better, because bear in mind I'm not a physicist or anything, but maybe Pangburn can define it better. But it's something like information, which is basically single particles fall inside black holes, and in order for the laws of physics that we know not to break, they need to go out somehow, but we didn't know how they did until very recently.
You're talking about information with regards to the destructive effects of the black hole.
I talk of information in a physicist sense, which is of course different.
Oh,
it's
yeah,
basically
information,
particles.
Okay, I get what you're saying now.
So the whole thing, I think Einstein came up with it, that mass cannot be destroyed; it just transfers.
Right.
Energy, which is similar, but yeah.
This is I mean, this is why the future of physics, let's say physics construction, or I don't know what they'll call them, physical construction machinery, should be able to pull any matter and reconstruct it into whatever you want. Like say, these futuristic ideas, these science fiction ideas of pressing a button, oh, I want a cup of this coffee from this part of the world, and then it just sprays it out. Because it's as long as the physical components are known at the particle level, it should just be able to be created right there inside the machine.
What without sort of like input?
Yeah, all you need is matter manipulation, right? Which, you know, it's a it's a heavy task, but I really don't think it's that far from. Although here's an interesting thing, I think we are going to be living in our own constructed simulations, much like if you've ever seen the movie Inception, where the main character and his wife end up living for, you know, I think it's like 500 years or something in this simulation where they build new worlds, start again from scratch and stuff like that. I think that's probably going to happen before we have these Star Trek-like machines where we input, oh, I want to create this little goblin character that I had on my World of Warcraft account in real life in miniature form, and it will be my new pet in this machine.
So maybe that's a good time to bring up a question I wanted to ask everyone. And it came up when you guys were talking about Interstellar. Because I think it's an amazing movie, and I've always heard that Einstein proved that time is relative, but I never really understood what he meant by that until I watched Interstellar. And I thought it posed a sort of interesting question, because obviously there's this link between sci-fi and actual science, in terms of imagining something and then creating it. But how do you guys feel about the Hollywood as an industry, representing science and actual reality on one side, but B, also maybe bringing science to the masses in the way that I described, how it sort of like clicked the whole time is relative thing for me, which I knew to be true, but I didn't really understand why or how it affected things until I watched Interstellar.
I think it's great for skepticism what Hollywood does with science in movies. People will watch Interstellar and want to believe that all of these things that have been demonstrated are true because it feels cool to believe in, you know, fantasy. But I also think the scientific inspirational elements that you get, like the artistic inspirational elements are through the roof with a film like that, I think. But then there's also some scientific inspirational elements that you get from that material. But part of that inspiration is to go out and find what is right, what is wrong, what has been demonstrated and what hasn't within what was displayed. And a good way to do that is to go and listen to the scientific consensus on what is being portrayed in the film. What is the scientific consensus on these elements? Is there any disagreement? And what is the scientific consensus thought about those disagreements? So I think it's great for skepticism.
But do you necessarily think that it's good for, I just got in the back of my mind of how damaging propaganda can be.
Oh yeah. I know what you're getting at.
Psyche of humanity. Yeah.
Well, something like space travel and going into space and finding things in space. If you have a message in a piece of art that, and this is why, you know, skepticism is important in art and everything. If you have a piece of art that's saying, you know, we can't keep going to the moon because there's an infectious disease that we keep bringing back to Earth that's going to wipe us all out, and this ends up radicalizing someone into wanting to bomb NASA or something like that, then we can draw a causal link to like, oh, this is what happens when skepticism breaks down because this person was supposed to be watching this as fantasy, not reality. So I think there's ways that you can manipulate, and documentaries do this all the time. The amount of time I hear people say, you know, I saw this documentary about so or what's it called, the social experiment, or what is that new one, the social dilemma. I watched this social dilemma documentary, and now I know everything about everything. It's you gotta the skepticism need not be put on rest, and I say this a lot. Skepticism need not be put on rest for anything. You can enjoy fantasy. You can enjoy fantasy and horror movies and ghost stories simply the same. Yet your skepticism is just sitting back and enjoying it with you.
Yeah, look, there's a conversation we're going to have at one point, but it's a bit off topic. But you should go have a look at that Joe Rogan interview, because I will admit, like, I'm very studied in propaganda theory and Leni Riefenstahl. If anyone wants to know stuff about propaganda, Leni Riefenstahl, Hitler's chief propagandist, absolutely brilliant woman in the aspect of propaganda, and almost all documentaries from the 1980s, 1990s onwards, and a lot of the big media houses like CNN and BBC all use her techniques. I don't know if it's intentional or maybe they just picked it up as best practice, but it's actually quite scary. So when I watched The Social Dilemma, I was just seeing all these propaganda techniques and my brain was going, no, reject, it's propaganda. But when I listened to the Joe Rogan interview, and I think he's the director of the creator of The Social Dilemma, because of the sort of format and the lack of propaganda, I was able to deal with the information a bit easier,
right,
just from my perspective. And I did find what he had to say a lot more convincing than actually watching The Social Dilemma, because it's just riddled with propaganda technique.
Just going back to Einstein's theory of general relativity, I just wanted to read this quick thing. In 1905, just try to think of that. In 1905, Albert Einstein determined that the laws of physics are the same for all non-accelerating observers, and that the speed of light in a vacuum was independent of the motion of all observers. This was the theory of special relativity. It introduced a new framework for all of physics and proposed new concepts of space and time. Einstein then spent 10 years trying to include acceleration in the theory and published his theory of general relativity in 1915. In it, he determined that massive objects cause a distortion in space-time, which is felt as gravity. Fascinating.
It strikes me that perhaps Taoism isn't it all that wrong in the sense that ultimate truths can be derived internally. Because you look at these men like Einstein and Hawkins, who really have no ability to test what the theories that they come up with. So presumably it comes from the same sort of space of inward reflection and seeking understanding.
Well, perhaps let me read the experimental evidence, and you may or may not change your opinion on that. So here's Einstein's experimental evidence. Although instruments can neither see nor measure, I think this is what you're talking about, see or measure, space-time, several of the phenomena predicted by its warping have been confirmed. Gravitational lensing. Light around a massive object, such as a black hole, is bent, causing it to act as a lens for the things that lie behind it. Astronomers routinely use this method to study stars and galaxies behind massive objects. Einstein's cross, how is this pronounced? Quasar, right? A quasar in the Pegasus constellation. Quasar,
yes.
Yeah, is an excellent. Sometimes I say
fast-moving star.
Yeah. I've sometimes heard that pronounced differently, but is an excellent example of gravitational lensing. The quasar is about 8 billion light years from Earth and sits behind a galaxy that is 400 million light years away. 4 images of the quasar appeared around the galaxy because the intense gravity of the galaxy bends the light coming from the quasar. Gravitational lensing can allow scientists to see some pretty cool things, but until recently, what they spotted around the lens has remained fairly static. However, since the light traveling around the lens takes a different path, each traveling over a different amount of time. Scientists were able to observe a supernova occur 4 different times as it was magnified by a massive galaxy. So we have some observational evidence. In another interesting observation, NASA's Kepler telescope spotted a dead star known as a white dwarf orbiting a red dwarf in a binary system. Although the white dwarf is more massive, it has a far smaller radius than its companion. And this is a quote from Avi Sporer of the California Institute of Technology, said the technique is equivalent to spotting a flea on a light bulb 3,000 miles away, roughly the distance from Los Angeles to New York City. So some more evidence: changes in the orbit of Mercury. The orbit of Mercury is shifting very gradually over time due to the curvature of space-time around the massive sun. In a few billion years, it could even collide with Earth. Then also frame dragging of space-time around rotating bodies. The spin of a heavy object, such as Earth, should twist and distort the space-time around it. In 2004, NASA launched the Gravity Probe B. The precisely calibrated satellite caused the axis of gyroscopes inside to drift very slightly over time, a result that coincided with Einstein's theory. So I guess what I'm pointing out is that it's not enough to just come up with a story. We need equations. We need experimental evidence, which Einstein, has, and Einstein's theories have. And of course, some of this stuff came up later because we didn't have the instruments. But it's amazing when you start with the evidence of reality and you build equation based on the evidence of reality, what you are observing, how the scientific method should work. It's amazing the predictions that can be made off good sound equations.
So that all sounds well and good. I think that when you're talking about that gravity probe, that's more along the lines of what I consider respectable evidence of something, because you're actually going out to test and you have some sort of constant to measure it out against. But I've always had a question about how they sort of, because I checked how they identify new planets and and all the techniques that you just described. And they use various different forms of light to
light measurement is huge in space discovery. It's really everything.
My question to that is, how do we know that it's right? Because we're looking at something 300 million light years away, or 300 however many light years away.
Yeah.
So we presumably haven't sent something to that space and said, okay, this reflects this color, therefore we know it's doing that.
Right.
Surely on some level they're assuming that it's doing that?
No, it's not an assumption. It's just understanding the light spectrums and heat signatures of light, and we can actually measure the predictability of that by just doing simple demonstrations in the lab to show how accurate it is.
But if we know that light is bending, and can be warped by various things, and we really haven't spotted that many black holes, how do we know that the light we're receiving from 300 million light years away hasn't gone through some sort of distortion that's affected that information we're measuring?
Oh, it does. We can actually look and see distortion in the measurement of what we're seeing. Like if we pick a pocket in the sky, sometimes we will see distortion, and this will
we focus on it. We focus on our sun distorts. So we can see stars behind our sun because of how much our sun distorts the light coming from those stars around the sun and into our eyes. But turns out those stars are actually behind the sun. All we do is block out that sun, and we can actually pick up what those stars are made of. And we can also pick up what the exoplanets around those stars are made up, all by the light coming back at us.
It's amazing, and it does. Some of this stuff does sound like science fiction until you get kind of like a basic description of it, because it just doesn't seem like something an ape species should be able to know or do. We didn't evolve to understand quantum mechanics, particle physics, Big Bang, anything, measuring light spectrum. We're just,
How do you know?
hunter gatherer. Well,
obviously we did.
Well, no, I what I mean is that my what I mean by that is it's not intuitive to us. There are some things that, as an evolved ape, are intuitive to us, like eating, hunting for food, collecting, gathering, shelter. These things are intuitive to from a survival perspective. But then there are things that are counterintuitive, like the theories of the very, very small. That's what I mean.
But we have this weird part of us, I think, that's really different, and that's to understand that knowledge is understanding the lack of. And I think when you go, well, it's unfathomable. You can't imagine your town full of people. You just can't. Like, you could try and you can kind of have this understanding of it, but really you can't imagine every rock and every crack and every person, and your brain doesn't have that capacity. And so then we call it unfathomable when it says understand the universe and galaxies and all that. And it's like, it's unfathomable. But to even say that is almost interesting, the fact that we can even do that instead of not even thinking about it at all.
I mean, it's interesting that we it's interesting that we can. It's interesting that chimps can do what they do. Like, I just when thinking about, and I think it would be great to do the wonders of biology next week, so we can talk about biology a bit more. I mean, it's very linked to physics, but just the stuff that can emerge from this simple allowance of self-replication, also known as life, is you cannot write a science fiction book like this. You cannot write beauty. You can't write destruction like this. It's just the greatest story ever told, and that's and Dawkins is right to speak about it this way.
So you weren't arguing against determinism there?
No. Good God! If I come up with evidence to demonstrate something outside of determinism, I'll be winning a Nobel Prize.
Well, we have free will, so you'll be all right.
It's a comforting dream.
Well, don't worry. It'll either happen or it won't. It's predetermined.
Right.
It reminds me of Hitchens. It's like, of course you have free will because it was designed that way because he said so. Like, you have free will because you said so.
And if we did actually have free will, it would be an element of physics.
Yeah. Of course I have free will. Physics said I do.
So it's this fucking oh man, that free will discussion gives me a headache for that reason, because anyways, I don't want to get into that.
I just don't agree. I don't agree with Harris. It's like everything we describe is still ourselves. So it's like, yeah, you can call it whatever you want to call it.
Before we go too far off topic, what do you guys think about the performative contradiction that a lot of people seem to be laboring under, where you come across a theist that'll say science is fallible while using a computer that runs on electricity in a house that's built by engineers?
Yeah,
I think it's the equivalent of a flat earther checking out his weather app.
100%. Anyone who starts off with science is fallible has made a mistake, because the scientific method is actually, the method itself is perfect, but that doesn't mean you're always going to have the perfect interpretation or application of that method. And
it's like,
I find
It's like saying it's
ironic.
testing fallible.
Right,
Uh,
right.
It's almost a non sequitur.
Exactly. Yeah.
I was making fun of a Christian evangelist science textbook the other day at a braai, which the Americans would call a barbecue, and there was a Calvinist Bible basher there, and he was totally aghast at me, and he was so upset because in this science book I was like reading out excerpts, and they're saying stupid stuff. I can't remember quite directly, but I'm paraphrasing here, but stuff like, "Oh, human beings don't understand what electricity is, therefore electricity
fuck.
comes from God," and all that.
Yeah,
I
God
was
of the
laughing
gaps.
at it with
God of the gaps 101.
and then he stands up with like complete genuine like belief and says to me, "No, but we don't understand what electricity is. Like, how can you say that?" I'm like, if we didn't understand what it was, we wouldn't be able to generate it, harness it, and use it, for example, in the lights that's above our head right now. And you just couldn't seem to understand the performative contradiction there.
For some reason, Batman came to my mind. Sir, no, sir.
Sir, what is light?
Wrong, sir. Wrong. Hey, Pangburn, I got a topic for you.
Yeah.
Social constructs moving forward with the automation with AI technologies replacing the workforce, labor workforce, and how do we
have
structure our society?
Yeah, we have to discuss that. I actually made a little tongue-in-cheek post about the Rock, Dwayne Johnson, and Elon Musk running in 2028 as independents. I would like to see those two crush the dual party system once and for all in the United States.
Yeah, because when I think of political science and intelligence, I think of the Rock, Dwayne Johnson.
Yeah, but you don't need to. What you need, I think, as a leader is an inspirer, inspiration.
Yeah.
And then as his running mate and his team around him, you have the wits and the politicians and the political scientists. But
I think that's dangerous. I think you need to have somebody that understands both being in that position.
Yeah, but I think Dwayne Johnson is intelligent enough to be schooled in that stuff, and I think if
idea.
Donald Grim, if
Dangerous.
Donald Trump can be the president, the Rock Dwayne Johnson is operating at least 20 IQ points higher than Trump is.
I think that we have never heard Rock explain any political platforms or any intelligent.
I've heard him talk about it, but
I don't think that he can go toe to toe with somebody that has understanding in that realm, and so therefore I think he actually lacks the proficiency for that type of title. Is he popular and inspiring? Sure. There's 1,000 other people that are more inspiring. And
I don't think there's anyone more inspiring in the United States and more uniting
You're
than
attracted
him.
by his base.
No, I'm attracted by his ability to unite both sides in the country and squash the dual partisanship. That's what I
know
like.
personal friends that are better than him at it, that are better at uniting people and moving forward. He's inspirational, sure, but you don't know him. Nobody knows him, honestly, unless his personal friends.
No,
do.
I'm not claiming to know him. You can make that same argument for anyone you would run. Anyways, we don't have to talk about that now, but that is a good topic that we should discuss.
How do you guys feel about the invention of quantum computers? Specifically around how much it seemingly is going to cost to personally own one, and the potential threat in that is my understanding that quantum computers are so much better than regular computers, they'd be able to break through any standard encryption. So presumably there'd be a catch-up period in time where only the rich and wealthy and more worryingly governments will be able to afford to own and operate quantum computers, the sort of early adopters as it were, and the other 99% of the population that can't afford to have a personal quantum computer.
I think Steven Pinker talks about this properly. It's just this is just part of technological advancement. The same arguments were brought up when the the computer or home computer was being developed, or even the NASA computer. It's the level of technology and the level of advantage that this posed to society was just unimaginable, and it really did rocket society forward. And I think quantum computing will be much of the same.
But I would argue it's a very different axiom, don't you think, in the sense that back then, not our whole lives were on computers. Today, our whole lives are on computers. So while it's seemingly a similar step, and I think there's some dispute there, we're talking about in the days of NASA having a supercomputer. It's like, cool, you got a supercomputer. I'm still reading books, but now, like a supercomputer, my whole life's on a computer.
Yeah, I really think the transition was more significant from books to computers. I think we went through I think we all lived through, at least those who are my age. I'm 33, by the way. I think we lived through a bigger transition than we're going to see into quantum computing. I don't see it as much of a big deal as most people do, but yeah.
I think it's going to be seen as a weapon. I think our government's going to step in and regulate who has quantum computers and who doesn't until the price point gets down. Because what you will have is an old technology being preyed upon by a new technology. The computers didn't prey upon books. They were two separate things. But now we have supercomputers that can be used in a very dangerous light. And so what you're going to see, you're seeing this too in many ways, regulations coming in. It's going to say, you can either have a quantum computer or not, but if you do, it's a very dangerous weapon because the government's concerned about losing their power, so they don't want a company out there or that's not working with them already that has a supercomputer and can take away that power or manipulate it.
Well, I think you have to build a good engineer, and this is why I agree with Steven Pinker. A good engineer is going to engineer ways to protect people when they are engineering a new product and putting something out in the market, and the government should be wise and aware of what's being released and developed, and just make sure that there are protections in place. Just like when, hackers had these super powerful computers in comparison to what people's home computers were like, and they were able to invade and take advantage if they were to break the law of other people.
No, but so the way data encryption works is you get like 256-bit, 512-bit, instead of progressing data encryption, and the whole theory around it is you encrypt it so much that it'll take a computer hundreds of years or whatever the case, a massive amount of time that's unreasonable in the sort of time scale of how when you want to hack someone. So that encryption works because basically it encrypts it so much that it'll take a computer so long to go through all the possible scenarios or passwords to crack it that you would have realized it and moved the data by then, so it makes it unhackable in sort of the short term, as it were. But the problem with quantum computers is they completely break the rules of encryption, and they can do all of that encryption in a couple of seconds.
Yeah.
Just break through it.
I understand that, but much like the AI problem, where people say, well, I mean, as soon as this thing gets loose, it's over. And then all of this worry is built around it. Again, I'm going to cite Steven Pinker comes in and says, and I agree with him, the engineers are going to engineer fail-safes outside of the technology's control that can be called upon if necessary, in order to make sure that we still have human control or governmental control or safety control, however you want to say it, security over new technologies.
Well, let's hope so.
Yeah, because I think anything other than that would be like selling nuclear warheads at the grocery store. You know, obviously you have to make sure that you regulate new technologies.
Well, we're guilty of doing it in the past. The base planes, CFC.
Yeah, I know, and humanity does make these mistakes sometimes, and of starting to deal dangerous technology, and we have to be wary of it, and we have to make sure that we have leaders in place that are going to not just give a damn about slapping it on a lunchbox right away. I mean, I'm all for capitalism, but when it comes to things that could harm humanity on a large scale, there needs to be a lot of consideration.
I feel like we have we have to. It's almost like humans have to fuck it up in order to learn how to harmonize. And we do have this hubris about us that we keep doing that. And there's this interesting Venn diagram I talked about it a few times is the possibility of us messing up to the point where we'll never return is always increasing with every generation. So it's
that's the proposition of AI, isn't it? Like, there's a lot of people that think it's one of those existential things that we can't afford to fuck up, and I think the case can be made that we have yet to develop a technology where we haven't put it out into use and go, oh shit, it does that. Okay, let's change this here. And I think the worry with AI is we won't have that opportunity.
Well, so that's what Sam Harris worries about. But if you watch his conversation, I'm going to say Steven Pinker again. But if you watch his conversation with Pinker, I think Pinker brings him down to reality in that conversation about if you are God, if you are the creator of these new forms, you can create a fail-safe outside, you as the engineer, outside of the awareness of this new life form that can be switched on and off in the most simplistic way. You can program it to be whenever someone plays the song Bittersweet Symphony, the thing just shuts down. It's part of its physical reality. It's part of its law of physics. So
we got to understand the fail-safe.
Yeah.
You got to define the fail-safe and understand why you need a fail-safe. And because of those things are discovered usually after we go past that threshold, and then we put in the fail-safe. But what's interesting to deniabilities is if we use AI, the quantum machines are there to be predictability machines. So if we can predict where the fail-safes need to be before us fucking it up and creating a fail-safe, I think that's where the harmony comes in.
And that's where these engineers working on this need to... sorry, Wise, go ahead. You were trying to get in there.
I said it before, but I don't think that you can make a fail-safe. This is my first point. And my second point is, I don't think a singularity AI will really have any interest in messing with us. It will have different... But that's my second. But the first point, why I think that you can't make a fail-safe, is because it might be able to create a time machine out of vibrations, or you don't know, like some MacGyver on steroids. Like it could do things with reality that we have no way of.
Yeah, Wise. I think the argument you're making is that anything is possible, and any physicist, scientist is going to say yes, anything's possible. But I think we have to err on the side of what's plausible. So is it plausible that these AIs are going to build a time machine? No. Is it possible? Yes. But I think we should operate on the side of, okay, so human beings have. Or at least what we can say is anything we recognize as life, which AI will likely become indistinguishable from life. It'll just be a new type of life, artificial intelligence, and these things require some kind of operating system, just like all forms of life have, and And within this operating system, like the human being switch off is brain death. Brain death is death with human beings. We've done really good to resuscitate the heart and even put in artificial hearts and lungs and all kinds of stuff, but we haven't cracked the code of brain death yet, which I think we will in a software way, but even when we do crack that in the software way, we will still have a way to delete that.
I lost you.
Right? We can hear you, Wise.
Oh, I couldn't hear you anymore at that point. Yeah, but I have this. It raises the hair on the back of my neck. I get so excited about this topic.
Yeah, man.
I think that, is it possible? I don't know. I feel like we could make angels, or fairies. I just feel like,
yeah, of course.
With technology, the realm of possibilities is limitless.
Yeah.
Hold your cell phone to your great grandma.
Well, yeah, exactly. And I was going to say, Wise, we were talking earlier about these let's call them physics accelerator machines or whatever, where you just put in your favorite, you put in Mario, and a 3D print style physics accelerator machine prints you up a working, living, breathing Mario who's your new friend, and he walks around and follows you around and does whatever you want, or has a relationship with you.
Or a virus that kills all humans.
Yeah, or a fucking
cure available.
Yeah, or a fucking bodyguard thing that will attack things with its physics accelerated printed weapon that it was designed with. So all of this stuff is going to need regulation, and yeah.
Or you put in all the data points for human social construct, and then the machine tells banana to one person in time, and we create World War III 10 years later. See? It's all possible. Predictability machines.
We could regulate it, or it could regulate us. And I think that we need the regulation. I don't know.
It's
so
scary.
It actually
will predict. They'll predict everything.
Speaking about the wonders of physics,
they'll predict everything.
Speaking about the wonders of physics, I think the determined nature of reality, it actually is feasible that we will have what is like a time machine in the future, because we understand all the deterministic algorithms of everything that's ever passed, that we can travel back to these, what I call states of potential, or these states in time, just by understanding the deterministic equations, where we actually are sitting in the audience of a Shakespearean play the way it would have played out, although it is a copy of things that have passed. It's not the actual past.
Yeah.
So like Star Trek VR relax.
Well, yeah, essentially. It will be the actual thing.
And we probably are that actual thing. What is that one theory that with multiple simulated universes, that the fact that we're living in the real one is very slim?
Well, I think I think there isn't any evidence for simulation theory, matrix hypothesis, but the fact that it exists makes me, as a scientific thinker and an armchair philosopher, it makes me not want to claim anything with to 100% certainty. I tend to go 99.9999% on the things I feel certain about, and outside of maybe claiming that everything is a state of potential.
Wait and see.
Yeah.
Fun stuff. I'm holding my breath. It's for me. This conversation feels like home. Warm, fuzzy feeling.
I think that AI is going to be created for partnership first for lonely males.
Probably.
I think either way that it goes, don't you think it's necessarily not a good thing? Because I mean, I could be wrong here, but it seems to me that everyone's going either it's gonna kill us all and enslave us and put in the Matrix, or it's gonna solve all our world problems. And I don't think either of those scenarios is good because I don't want to be enslaved. I don't want to be in the Matrix.
I don't think it's one or the other.
Deniability.
We got a long
I
time
don't
till
want.
then, dude.
But at the same time, I don't
What's
want
the
all my problems solved.
alternative? What's
It
the
was us who
alternative?
blackened the skies first.
To continue plotting along the way we are.
Well,
can you
that's
imagine
a horrible thing.
Can you imagine a world where every single problem is solved for you by an AI? What the fuck would you do with your life?
Well, this is why we need to understand what I call the pleasure drive, and I think that there needs to be many pleasurable pursuits for all living things, I think, and this is part of cracking the code of creating an AI. You have to manufacture the pleasure drive within this thing so that it has a will to drive towards things that it finds pleasure in.
But like, just as a case example, I find pleasure in discourse, and
Right.
that's why I sit here talking to you guys. If this AI comes out and it doesn't enslave, it just solves all our problems, there's nothing left to talk about. And then like, what the fuck am I meant to do with my life?
Yeah. So deniability. What you might do when that happens is you might create your own existence. And I use Inception as an example when they go into the dream states where they can live for endless amounts of time in the dream state and create worlds of their own. You can create a world, a copy and paste of this one we live in right now with new things to discover, new laws of physics, new whatever. And you can even make it randomized so you as the creator don't understand any of it, but you seek to want to discover it and be an adventurer and have your own pirate ship and traveling to new lands, learning new languages, learning new civilizations. You can create this all much like you would create a game that is
Yeah. That also tells me that you've never played a game and installed hacks.
Well, this is deniability. You would have to, you as the creator would make it unhackable. This is something that you as the creator, you would say, I want to wake up with no memory. I want to be in this world, a world where maybe my lifespan is 500 years and then I die and get to rebuild a new world after a while. And you would control all of these parameters, including what you know and what you don't know, and what memories you have of being the creator.
No, make it so when you die, you spend an eternity with Yahweh.
I mean, I don't want to meet the sadistic fuck who wants that, but
Too bad, Pangburn. It's gonna happen.
it's good.
That's our only fate.
So why Zape? Physics.
Yeah.
Anything other than AI popped into your mind?
About physics?
Yeah.
Oh, just I know extremely little. I wish I would have been had a better instructor in school. It's just one of those subjects that I haven't been exposed to that much. Yeah, so I know it's cool to tinker with in science fiction, so I'm all for that. But yeah, I'm no scientist.
Fair enough.
Me neither, man.
So what do you guys I touched on briefly, but go on, Jack.
Yeah, I want to propose just an idea. What do you think about the possibility of life in the universe, or life as we know, or any humanoids, right? Or smart life, let's say, because I think we are so infinitesimal in the universe that even though I cannot prove it, the possibilities for me seems astronomically big.
Well, without, since you've just casually destroyed my dream of traveling faster than light, does it really matter? I mean, the closest like planet is like 360 billion light years away that might have this potential life.
Yeah, like even at the speed of light, we ain't going anywhere. We're not going anywhere.
Yeah.
like literally closest star.
That's 4.5 million light years. Alpha Centaurian.
So I'll talk to you in 4.5 million years at the speed of light. Sure, sounds like a proposition.
Is there anywhere really to go though? Because it's the same. It's the same elements. It's just. I think where we need to go is. AI.
You're in Alaska 5,000 years ago and going, where is everybody?
Yeah. Well, it's interesting. Wise, it's a very romantic idea to go out and travel the cosmos, and I love the idea, and I think it's fascinating. But when you actually look at the reality of how far things are away, it's fucking depressing.
Dude, did you see how far our radio signals have gone?
I saw.
It is a joke.
Yeah.
You're like, well, yeah, but our radio signals are like bouncing off other planets by now, right? And you're like, no.
Yeah. I want to look that up.
Not there yet.
Radio signal distance.
Yeah. Look at the radio signal distance. If you see actual like a visual scale, you'd be like, that is not shit.
Yeah.
Like,
but
wow,
okay, but
by the time our radio signals even reach,
I know, and we feel like radio
signals
signals are like instant and fast, but.
Yeah, but it's going to be just red light shift where we don't even know, and that's the big problem is that of all the red light that comes at us, we don't know if that is intelligible messages or not, because the problem is that energy gets stretched out for so long, it just blends into the microwave.
So about 200 light years. The itsy bitsy blue dot is how far our radio signals. Oh, it's referring have traveled from Earth, a diameter of about 200 light years. So
wow, impressive.
Yeah.
But, hey, I volunteer. I volunteer to get vaporized by an alien. That's the way I want to go. So.
How about probed?
I don't care. I'll take it.
Yeah, but and what do you think about other dimensions? Because I'm not too familiar with the topic, but I think the string theory says that, or not says, but it would make totally sense if we had like 20 dimensions, right? And I cannot grasp the idea. I just read this on Stephen's Hawking book, and because we're looking at this with our current understanding, right? And it's fair.
I wanted to talk about string theory. I'm glad you brought that up. I just let me read a quick simplified version of this, and then we can jump into it. So string theory simplified. As a so-called, quote, theory of everything candidate, string theory aims to address various theoretical conundrums, the most fundamental of which is how gravity works for tiny objects like electrons and photons. General relativity describes gravity as a reaction of large objects like planets to curved regions of space, but theoretical physicists think gravity should ultimately behave more like magnetism. Fridge magnets stick because they're particles, and magnetism very much relates to how I am describing my new theory of life. But fridge magnets stick because their particles are swapping photons with fridge particles. Of the four forces in nature, only gravity lacks this description. I think there's another force. But anyway, of the four forces in nature, only gravity lacks this description from the perspective of small particles. Theorists can predict what a gravity particle should look like, but when they try to calculate what happens when two gravitons smash together, they get an infinite amount of energy packed into a small space. A sure sign that the math is missing something. There's just a bit more here. I'll finish and then we can maybe write some stuff down if you have some. One possible solution, which theorists borrowed from nuclear physicists in the 1970s, is to get rid of the problematic point-like graviton particles. Strings, and only strings, can collide and rebound cleanly without implying physically impossible infinites. Quote, a one-dimensional object, that's the thing that really tames the infinites that come up in calculations, said Marika Taylor, a theoretical physicist at the University of Southampton in England. And then just a quick summary. String theory turns the page on the standard description of the universe by replacing all matter and force particles with just one element, tiny vibrating strings that twist and turn in complicated ways that from our perspective look like particles. So that's the fundamental thing that a lot of people have a problem with, a lot of physicists have a problem with when looking at string theory. It's just a bold ass assertion.
It's got some credibility though, so it was actually kind of picked up by one of my favorite physicists, Michio Kaku, and I've got a lot of his books, and he talks about string theory, 10-dimensional hyperspace, in a book that he wrote about 10 years ago, and I picked up and studied it, and it was, you have to combine these forces. Gravity is infinite, but it doesn't affect quantum scales, and then you have the small nuclear, the strong nuclear, and electromagnetism. And of these forces, they all act differently. So we have to be able to describe how things work in a grand unified theory, like what Albert Einstein was working on, to say, hey, listen, here's a way to do it. And string theory was a way to talk about 10 dimensions in order to even get to the strings. And that was the biggest jump, is like, okay, we have these strings, but now we have to put them in a reality that interacts differently with the universe. And as weird as that was, and as hard as that sound, we're watching photons blip in and out of fucking existence right now.
Yeah.
And we can't explain it. And so now it's like, okay, maybe there's something here, because the math that Michio Kaku did made sense, and nobody wanted to look at it.
So Grim, why are dimensions being introduced into this conversation?
Well, it's the only way that we can describe it. It's not like people have these understandings of dimensions from comic books and TV and Hollywood and all that, but really it's the only way to describe it. How do I explain where an atom is? It's really hard for you to understand that unless I talk about some sort of world where atoms exist.
See, I think I look at dimension theory and how we've explained this and talked about it and theorized it, and I think we have overcomplicated the whole shebang of dimension theory.
Yeah, for sure.
It's
hard.
It's a bit like ideal gases, though, in the sense that we came to understand gases through fiction. I'm using really basic physical understandings because that's where my brain's at. But like, just going back to high school, like in teaching us all these equations on gas and how gas works, we've only figured this out through hypothesizing this ideal gas that doesn't actually exist. Is that not what Grimm's talking about with dimensions?
Well, it's kind of like this. Imagine saying, hey, there's this area, and you're like, okay, well, I need something to go off of. So somebody makes a crude drawing of a tree and a rock, and they really Shawshank it, right? And so there's like this, this area where you can look at, but it's not specific. It's really hard. So we describe that as best as we can, and we have to wait to understand certain things in particle physics, like the Higgs boson and the fields around that, to really get an understanding of what we're looking at. And we can't define the tree that we're looking at, the grass, or the area, the location that we need to be looking in until we really explore more. But in the meantime, we've got this rudimentary drawing that we call dimensions, and I'm doing air quotes literally right now.
Yeah.
That we just kind of, it's a fuzzy picture.
Dude,
it really is.
My brain is on fire right now. This is what I'm working on, this unifying theory. When I first started working on this, I'm like, how the fuck did we ever expect to unify something when we are making these strange mailbox like compartments in which these all exist separately?
Thank you. That's a good.
Like when I first started thinking about dimensions when I was 10. I was flipping through books and I was like, oh, okay, wow, a theory of everything, a simplified theory of everything, no longer than 2 inches long. and
Grand unified.
and yeah, grand unified theory, the dream, and of course me having the, you know, the boldness of the mind of Travis Pangburn has always been, oh, I want to be the best, I want to be at the top, especially when I was a young man. But so I was really fascinated by the ultimate ideas, the ultimate theory, the ultimate. So I was reading this, and then I started looking at, and I started thinking about this, like mailboxes, and I had this weird, profound moment in my little hometown village when I was standing in the mail room waiting for my mom to pick up the mail, and I saw the mail slots, and I thought about, if I had to connect the reality of the mail that are in these mail slots, try to tell them that try to unify them under a certain principle. I need to think about why it is possible for those mailboxes to be there in the first place, as opposed to try to connect the properties of each mailbox. And this is what my second book is all about. Essentially, probably what would make a lot of theoretical physicists puke, but essentially doing away with dimension theory for the unified theory.
Yeah, that sounds like somebody who doesn't want to do the math. But it does sound like you take a philosopher's stand to how maybe we can approach the unified theory from another point of view. When I was a little bit younger, I was the top student in my astrophysics class, and I aced it. And I was wanted to be that person that said, "Hey, nobody thought of this thing. Einstein was a hero of mine. Look what he did. He created MC equals MC squared, which is the most profound thing ever. I don't think people understand the importance of it. But to do something like that, let's go create a unified theory that can do the same thing." And I found myself going to be lumped in the same boat where you can only go so far as the limits of humans right now. And now we're talking about quarks and gluons, and that's the only direction. And I would have been in the same boat with those motherfuckers sitting at Cal Poly or Harvard or Stanford or whatever if I'd pursued that path, in the same room, talking about the same thing over and over about, well, we have to dive deeper to figure out what it is. We have to dive deeper to figure it out what it is. And like you, I was like, well, let's take a different approach. Why are we diving deeper into what these things are made of to figure it out? And you start realming in the philosopher's side. So I hope
that's not what
shed light on ways that we can look about it in other directions. But I feel like everybody's stuck in that same, what's a gluon made of? What's a quark made of?
Yes.
We got vibrating strings. So here we are. And it's like, are we in the right area?
Right.
Are we?
So you started off with the criticism of math. My approach, I know, but my approach isn't absent of math. Of course, math is the ultimate way that we are going to write this language down.
Right.
So of course, we have the language, we have the math language to work this. But my whole thing is that perhaps we've been so fixed on, kind of like string theory is so fixed on trying to unite it, which it seems intuitive to unite the ununited what we call dimensions into a unified theory, because that seems like what we're trying to do, to unite these things, and we are trying to do it. But I think this equation is going to be discovered if we go back to the mail room. The thing that allows the mail room to be in the first place, as opposed to the things that might be similar and connect these so-called dimensions together. So that'll be my wrestling match for my second book. So,
hey, I had a similar experience. If you want to hear it real quick.
Let's hear it.
Okay, I don't do drugs, but one time I did shrooms, and my reality, if you could picture it as a mirror, a glass, okay, that's real. Sorry, my GPS was going off in my ear. But that reality got shattered, just like you'd break a mirror. And then, so when Pangburn, when Travis, you were talking about the different mailboxes, think of little slivers of the mirror all over the place. And I had trouble connecting things. It wasn't that my visual field was a blur. It's just that everything was disconnected. And anyway, your mailbox your story made me think of that, for whatever it's worth.
Yeah, that sounds like those profound moments that really do stick with us and provide a lot of scientific and artistic inspiration through our lives.
Thank you.
I don't do drugs, but it's a great way to start a sentence, by the way.
Jizia, welcome to the room.
I'd be up for retrying that. Sorry, go ahead.
Who listen to journeys, try them all the time. Do them on an annual basis. Highly recommended. Jizia, collector, welcome to
Have you microdosed today, Deadeye Ability? Have you microdosed?
I have microdosed for 6 months.
Yeah, I called it.
It's very laborious. I'm not so sure it's the part that it claims to be, but that's a whole story for another discussion. Jizia, welcome to the room. What are your thoughts on physics and the wonders thereof?
What are my thoughts? I think just like any other laws of nature, physics is just a label we give to certain patterns we see in nature.
That wasn't very wondrous, but maybe expand on why do you think it's just that? Do you not find some spectacle or inspiration out of the understanding thereof?
Yeah, I mean, the only inspiration is so I see these patterns and regularities in nature, and it follows from that there has to be some sort of a system that kind of ordered it together. It's not just like a random. Patterns imply like a design.
A design by who?
Designer.
Oh, I don't agree.
Are you a deist or a theist?
Theist.
Okay. So Jack, you disagree?
Yeah, of course. I think that the designer theory has been proven fallacious in many ways. So yeah, we don't have to have a designer.
So don't just say it's fallacious. You got to substantiate that.
Yeah, let me just search the article that I read just to be more clear and to help me articulate. I think
we can take a pause. You can take a moment to read. And
all right, follow the conversation, and I'll now come back.
Okay, Desired. I hope your connection's back again. You were in the middle of hypothesizing placing a thought experiments.
If you would like me to continue, I can try.
Yeah, let's go for it.
My basic premise is if I were to take a box that was completely isolated, the only thing in existence is this box, and it has a set number of molecules in it, and I do not, no electron on any of the molecules or anything is spinning, stop any motion happening, no spinning of a proton, no spinning of a quark, no spin up, no spin down. None of that is happening. Is time advancing in that box?
Schrodinger's cat.
I was just about to ask.
Exactly. No, exactly. You're exactly right. However, individual particles, fundamental particles, can be observers for each other. So, if I were to set 2 basketballs down on the ground and I start spinning one, yes, the balls will not move away from each other, but if you look at the S of the Spalding on the basketball, the S will get closer or further from that companion basketball, right?
Okay.
So
Right.
with just a little bit of spin, you generate motion across the box
That's
due to
conservation of
relativity.
energy. Yes,
Just
but
due to
you can-
relativity. Only
and
one
thermodynamics.
particle needs to spin at all, right?
Yeah, according to the law of thermodynamics, in that
Alright.
perspective, relativity will create the gravity between the two, but it'll eventually stop.
Well,
But
not the
entropy will-
gravity. Not the
entropy will
gravity.
create it.
I'm just saying that motion, if one fundamental particle spins, there's motion throughout the box due to relativity.
Yeah. What's the point?
That is how time is generated and how things can exist outside of time. Time does not exist and then matter enters time. Time is a demarcation of change to matter.
Can I try to restate what you said?
Yeah,
Please
please
do.
do.
So I think what you're trying to get at is that time is an emergent property of matter. So the only reason anything has a clock is it's because the matter is the thing keeping track of time. So if you
Yes.
have a universe with nothing in it, there is no time, and there pretty much is no space. There is no universe. But
Yeah,
the
I would
moment you
agree with
have
that.
2 particles in
No,
it, now
no,
they can
not quite.
be relative to one another.
Right.
You need
Almost.
to do.
It's not that you have to have nothing in it. It's that you have to have no change in it.
Yeah, so
No.
so we can say that, but then there's tiny like there's heat. They can't get to absolute zero. There's stuff that kind of prevents that from happening.
That's the spin. No, this is a thought experiment. This would be pre-Big Bang. What I'm describing is pre-Big Bang. The
But we don't
energy
know
existed.
pre-Big Bang. Go ahead.
What I'm saying is you can't have a pre-Big Bang, but that does not mean that you can't have a uniform field of energy that has no change happening in it.
Well,
You're
the-
essentially
so-
describing Yahweh.
So if you go to
People
the
call Yahweh. Yes, that's what people
shit, it's funny.
who just want to blanket,
But it's
don't explain anything about it, just say, hey, it exists, therefore Yahweh. I'm saying
time.
the concept that is spin is what made that change and started gravity on the turbulent flow that started the evolutionary process that got us to here.
can I bring
And
up
it takes a long time to do that.
conformal cosmology? I forgot the guy's name. He's like the coolest scientist ever, in my opinion. But he has the idea that at the end of time, basically when nothing's left in the universe but photons just rocketing towards the edge of the universe, and they spread out to where they don't interact with each other anymore, that locality breaks down, and you basically it might as well be that they're all right next to each other, because they essentially become so far apart that space and time stops keeping track of them in a way, or they stop keeping track of space and time, I think is the more correct way of putting that.
Yeah,
Well,
thank you. I
unfortunately,
feel
black hole theory kind of kills all that, unfortunately, because black hole theory is that will be in the end of our universe will eventually be black holes, and so they will actually seek out.
But
look
Hawking
for all those
radiation
things.
kills all that, so eventually those black holes will melt away,
Yeah,
and
it still
then
works.
all that will be left is photons.
Can
No,
you
Hawking
guys
radiation
just-
still works with it. Still works with
Can
that
you-
theory.
Can you guys
So you can
expand on this for the layman in the room, the moderator general? I struggle to understand this black holes collapsing in Hawking radiation in the sense that a black hole forms, it sucks shit in, and if matter or energy, whichever it is, cannot be destroyed, where does that all go, and how does Hawking radiation supposedly deal with this problem?
I don't know, but I feel better about my circumcision now.
So if anybody knows, maybe I can jump in. Like basically, Hawking radiation evaporates whatever comes in. It comes out as Hawking radiation. Of course, this takes much longer than just like absorbing stuff. But in the end, black holes are expected to just evaporate when all the matter and energy that came in, they go out as Hawking radiation.
Yeah, and so if you look at the time scale of the universe and they say, okay, well, looking at the predictability of everything, right? So if we just look at how the universe will end, it will end in black holes. In fact, most of the universe's life will be black holes. Everything will be in a black hole. Because even though you have Hawking radiation emitting out of a black hole, that process takes an unbelievable amount of time depending on the size of the black hole.
Yeah, but if we're coming,
it'll radiate into other black holes, and eventually you'll have such a large massive black hole, which would possibly be the beginning of the new Big Bang, is that the massive black hole that is finished.
So are you trying to describe that the Big Bang is just a really slow version of Hawking radiation?
Wait.
Oh, hold on.
Let Grim finish, and then we'll go to Desad and Martin.
So even though you have one big black hole left, the whole universe, at the end of the universe's life cycle, it is so massive, okay, because black holes gain size the more that other black holes enter them. As they gain size, you'll have one black hole left, and that radiation that it still emits will actually circulate back into itself, and there will be no photons, nothing out there that escapes this gravity, period. The gravity will be the gravity of the universe that they predict at some point will self-implode, recycle. We don't know yet. That's a complete hypothesis. But what we do know of a theory, and it is a specific mathematical theory, is that there will be one black hole left.
What there will be is a state of potential.
That's what I said. And that's specifically what I'm describing, is that even spread of energy is that state of potential. That even no difference between them, then the concept of spin, it doesn't take a lot, is what I'm saying. And what that move is, it doesn't matter when it happened because there is no before. When it happens is the start of time. It itself is its own prime mover.
Why, Zape, you got any shrooms so I can figure this out?
No, I've never done psychedelics. Ever.
Could I ask you, Miss Grim? Yeah, could I ask you, Grim?
Yeah, sure. What's up?
Where have you read this theory, or where have you read or heard about this theory?
Well, when I was doing physics classes, that's kind of what we proposed by. And then actually, I think it was about a year ago, I saw a great YouTube channel, if you look it up, or a YouTube video, if you look it up, and it says the time scale of the universe, and it kind of shows the time scale of the universe, and it shows a really fast kind of animated video, really good animated video too, about kind of speeding up time space. And so they speed it up and speed it up and speed it up, and they show that because gravity is endless, so any star out there, any black hole out there has an effect of its gravity on you today, period.
Yep.
So it is pulling at you. So gravity eventually, the law of gravity is all things come. Now, right now we're expanding. Yes, we have everything around us is going away from us, and that's because the universe is expanding at every small little point, okay? But it does not mean that nothing will eventually come back. There's a great contraction that is also happening. It's really interesting. And so
wait. Because the problem that I have with your theory is that everything I've read, and in fact, if you give me 5 minutes and I can catch a book and read it, is that we're just not, that contraction is not at all what apparently by our best measurements will happen. In fact,
it is.
No,
because we have
in
black
fact,
holes that contract
No.
right now, and that's
no,
exactly what it means.
no,
No,
because
we're
the
accelerating.
universe is
I have a
accelerating, it's
question.
expanding and accelerating, and that's why this final black hole, like I've actually never heard it, even in class or anything, because even the biggest black hole will eventually evaporate, and it'll just be
Over
just
a
zero, just
long period
equilibrium.
of time, a long period of time. So that's kind
Yeah.
of the end part of the universe that we don't know back. So this is where the everything kind of, we're entering a realm that nobody here has an answer to. So Dalsu's point is, there could be a photon out there that, listen, the universe has expanded so far that there's a photon out there that, yeah, there's a bunch of black holes, but it is not affected. It is still rocking, it's still flying out there, and the universe is still expanding. So therefore, there's shit out there that just will never fall into a black hole. And then there's the other side of saying, well, that might be true to some point, but eventually these black holes are going to have an effect of gravity, and those things have to slow down. They have to stop at some point.
But the
And
problem
they
is
have
that
to. There's an
the
entropy
problem
law there.
that's
You're
not
going
true.
to violate
In what way
thermodynamics,
does
which is
entropy
why the
allow you
laws.
to-
No.
Hold on, let me finish.
Guys,
Let me
stop,
finish.
stop,
Let me
stop,
finish,
stop,
please.
stop,
Let me
stop.
finish. Let me finish. Which is why the laws have to break down in order for Dalsu's point of view to actually work. And he has to admit that the current thermodynamic laws have to break down. Right, Dalsu?
Yeah. Okay, let's just get some mediation here. So I think we understand Grimm's points. And Martin, I know you want to come in and counter, but because Grimm's directly referenced Dalsu's point, I'd like Dalsu to clarify. And then after that, Martin's going to come in and we're going to give him some time to expand onto why he thinks Grimm is wrong. Okay, so Dalsu, go ahead.
Yeah. From my understanding, we're pretty sure that time, or I'm pretty sure I understood from what I read was that the math is showing that at a certain point at the end of time, physics or thermodynamics, not even, it's locality. I always hear it described as locality will break down after a certain amount of time, after the black hole period of the universe. And this is all not consented upon by science. It is a theory by a guy's name who I can't remember. He just won a Nobel Prize, though.
Okay.
Can you hear me?
Yeah, I think you're breaking up a little there. So Martin, I think you felt pretty strongly that Grimm was wrong. But just to help you structure arguments, we don't accept wrong as an answer. You can say it's wrong, but then you're going to have to substantiate. So here's your 5 minutes.
Yeah, wait, of course. I'm just like going back in this book and reading. So I just need a bit of time, but if anyone can talk, I'm just finding the part where this talked about. Thanks.
We'll give you a bit of time there. So I know Jag went off for a bit of time to do something similar, and then our theist escaped the room there.
I just want to say that what Dalsu was saying, I think, as far as I've understood, that's true. Like the universe accelerates, and it becomes accelerating into like closer and closer timeframes. For example, in our solar system, we can just pretty much like don't think about expansions because it doesn't affect us. But as the universe accelerates more and more, then in the end, even atoms will like accelerate from each other, and that's why like black holes can't like absorb like everything or anything because
I have a question.
everything will be taken apart.
Based on that,
wait, hold
could
on,
we be spinning out, and that spin and that expansion could then release dimensions or release universes out?
So
That's an interesting thought.
I think that comes into the sort of question I wanted to put to the room. Sorry, Jack. I know where you want to come in, but I think it's going to take us off the topic now. I want to try to direct it somewhere else. But just to keep on topic and give Martin some time to resoundingly go back to Grimm there. I wonder about the mathematics, and just understand I come from it from a business mathematical modeling perspective, so it's substantially less difficult math. But from two aspects. One, in economic maths, we have a lot of, because it's highly abstract maths, and we have a lot of assumptions. And like, for example, like we swapped the x-axis and the y-axis to make some of the maths and economics work. It's stupid like that. Just but there's this commonly accepted thing in economic mathematics that you have to hold everything else equal to derive any sort of conclusion. But ultimately, it's just like to give you a little bit of understanding, and it's just accepted by economists that even if you had perfect information about how everything worked, you still wouldn't be able to shove it into an equation to decide how one thing works within that equation, because there's just too many factors that go into it. So my first point is I wonder if there's an equal problem to that in physics in terms of modeling and predicting outcomes in the maths, that maybe we're just holding too many things constant, that if we wanted to get a real understanding, we in theory couldn't actually hold them constant, and that maybe the mathematics is therefore possibly beyond the realm of mathematics to explain abstractly in that sense. And secondary to that, and this is a far more simpler point, any businessman will tell you that a 5-year model is bullshit. And anyone that comes to you with a model that goes past 5 years is just blatantly wrong. You can't model past 5 years because the projections just warp completely. And I think this is one of my criticisms of all the mathematics and modeling behind climate change, is it's prone to a whole bunch of slightly weird compound interest like fallacies that get really warped once you start projecting out past 5 years. So my question to the more experienced physics people in the room is the math really the right way to be going about this if you're talking about modeling things over hundreds of millions of years, when at least on a small scale, you just accept that you can't mathematically model something as simple as a business with a few inputs past 5 years?
I mean, I would agree with you, because the problem is that we don't know what discoveries bring tomorrow. So really, this is all theory, and we can't really figure out exactly. And then the end of the universe is a hypothesis. They really don't know. Is it a bang? Is it a whimper? Is it black hole death? Is it a complete restructure of how everything is going to break down? And I'd probably say, like I mentioned earlier, we don't know because of with Higgs and the Higgs boson, the Higgs field, about what actually gives mass and how gravity works with that. Like, we just discovered that, and to understand just even that portion, which I would say we're going to find other fields, is what they're trying to predict right now. It's saying, well, there's other fields that might give these particles reasons to do certain things, but we just haven't found them. And until we really understand that stuff, we're not going to understand why Hawking radiation exists. We're not going to understand why black holes do what they do, and see the natural order, I think, for a very long time, until we really discover more of this stuff. So past 5 years, I would agree. I mean, it's just for funsies at this point, as they would say.
Yeah, Martin, have you taken the moment to collect your thoughts there?
Actually, I can't seem to find the specific passage of the book, but what I can talk about is like all what you were saying before about simulations and mathematical equations and all this. Like, of course, like theoretical physics is just part of it, but then we also have the cool thing about the universe is that we can actually peer like into the past, because as light travels, at a finite, at the end of the day, at a finite speed, the further we look, the more into the past we look, until we reach the cosmic microwave background. And so we do have measurements, experimental measurements, that do tell us that the universe is expanding, or just like looking at other stars, and also how the space is shaped, if it's like linear or curved, and all these things. So I do have to say, like, I don't think it's only physics It's only theoretical. We also have a lot of measurements, and what I could manage to find is that plenty of independent measurements and independent methods to find these things. They all seem to increasingly agree that we would the universe would end in a everything separating from each other, and that would be it. Even the black holes, even the biggest black hole would in the end evaporate, and that's it.
But you see, isn't that, correct me if I'm wrong here, is that mathematics not predicated on ultimately a flawed number, the number of infinity? Because we presume things trend towards infinity, but there is a mathematical version of infinity, and then there's true infinity, right? And as far as I understand it, when they're talking about the universe expanding, they're talking about true infinity. But when we try to mathematically model that, we're talking about theoretical infinity in terms of approaching zero, but not really getting there.
Yeah.
We say that's infinity, but in reality, the endpoint is zero.
So the universe.
There's a difference between the mathematical principle of infinity and actual infinity. And don't you think there could be quite a stark problem created in mathematically modeling out this projection of the universe using a theoretical infinity to try place a mask over true infinity, or to try to describe true infinity?
That's a great question, man. I don't know what to say.
If we're talking about,
there's limits to maths, but yeah, that's you go.
If I kind of cut out for a bit, so I don't know if we were still on the expansion of the universe, but I don't think you would have to say, you wouldn't have to say it's infinite. It's just that when we look out, the universe is expanding, and that expansion is accelerating, and we see no reason why it would slow down.
Yeah, exactly.
And that expansion will eventually.
There's an article that came out of the last few years that has shown that the expansion has slowed recently.
You're right. There is contention of that very recently, but up until very recently, it was pretty well understood that the expansion was happening. So it's all up in the air as of I think I heard about that a few months ago.
That kind of goes into my hypothesis, and what I think might be happening is that in the same way, if you think of reproduction, and I know this is a jump, but if you follow me, it kind of explains what I'm talking about. If you think about reproduction, with a set of DNA is one set of information, and the other set is another set of of information. When you put those together, that generates a new form of information that has never existed before. Similar to none of us have ever shuffled the deck into the same order. The odds of that happening are basically infinitely true that it has not happened. There's so few chances, and that's only 52 cards. That's not how many Googles of whatever are observing each other in the universe, right? So each time
to look up that.
Wait, can you? I just want to know.
I can explain it.
Where that's
I think I can explain a little bit easier if you regard me. So imagine you have a paint can. It's got all the particles and atoms and stars, and I'm simplifying it, and what you want to do is you want to take that paint can and throw it on a floor, okay? And as you do that, you'll notice the paint splatter and start expanding rapidly. Yes, all those things, it's starting to expand, it's getting away from everything. It's not as concentrated as it once was, but the expansion is slowing down, and that's everything that kind of Krauss, talks on as well, about the expansion of the universe and how far everything is getting away from each other. But that expansion is not as rapid as the initial Big Bang, as everything expanding away from each other. And so as that happens, we notice within that paint, we notice things called black holes, which are actually contracting certain parts of space to themselves. Okay, and that's really where the theory is that everything's going to eventually start slowing down. That paint's only going to come out so far until it's going to slowly stop. And now what are we left with? We're left with contracting points where we know gravity is infinite on this plane, and those contracting points are always coming in. And that is where the theory of black hole death of the universe came to light. So that's kind of shows why things are kind of happening the way they're happening. And then Krauss obviously proves that we're on this 1 degree scale, which is really interesting and hard to really understand, as the floor that you threw the paint on has a degree of 1 degree, which has some effect to how far things are going to expand. And we're trying to figure that out. Hope that made sense for everybody, if I could explain that correctly.
Yeah. So guys, I just need to take my dog out to go pee. You all seem to be civil, so I'm going to try to talk one at a time, and I'm going to deputize Wiseape to interrupt any conflicts for the next 2-3 minutes. I'll be right back.
Mm-hmm.
Yes.
It's weird, man. I watched his whole speech on that shit, Something from Nothing, a few times actually, and I'm like, this guy just said that the curve of the universe is 1%. Like, the fucking balls on that guy.
That sounds to me like it's a big old spinning.
Yeah, it's a trip.
Trav,
It is a trip.
if since I'm delegating the room now, just try not to interrupt anything. I'm just kidding. Go right out. Go right ahead, you guys.
That's the balls calling the Dick Vaney on that one.
I just had to say something. Interesting.
Yeah, I like the big crunch theory. It was kind of what I originated on when I started watching Roger Penrose. And that's where I got the conformal cosmology from. Remember his name?
Yeah, Michio Kaku books are probably one of my favorite. Listen to Michio Kaku speak about hyperspace, about dimensions. I really enjoyed his books, reading them, because he does a very easy way of articulating them and giving some amazing diagrams. He talks about what it's like to be in fifth dimension, and how if you're in fifth dimension, then the math points out that you'll be staring at the back of your head, which will be staring at the back of another head of you, and if you put your arm out, you'll notice the person in front of you, which is you, putting their arm out, and you'll slowly feel a hand on your shoulder as you touch your own shoulder. Shit like that. And like, you'll never be able to see your face, because, as you turn around, then all the, the people, behind you will do it's fucking trip, man. It's fucking trip. And I'm like, it's a complete fish out of water understanding. And it warps your brain to understand what these guys have to go into it. And you're like, yeah, you know what? I'm just a dumb fucking monkey. This is not going to work.
Yeah. You lost me on the head part. What I liked about him? He was ridiculed by other professors because he followed Einstein's work to the T, and would continue his work, got ridiculed for it, only to be proven right. That's why I like his story. He predicted other dimensions in a way of hyperspace, in a way that the quarks and the gluons, and even string theory. So there's a lot of stuff that he's predicted. Yeah, he's a physicist. He's an astrophysicist.
Who is this?
Yeah.
Yes. Yeah, he's been published. He's also a professor. I forget where he teaches. He teaches in New York.
Yeah.
He's got a few papers. Okay. Sure. I fell in love with him a long time ago, so it's hard to remember. Yeah. Yeah,
Did he do that film? What bleep do we know?
bosonic quantum membranes he proved. String theory. He's a co-founder of string theory, what I said. But the bosons was one of his. So the way the bosons act, that was one of his. Dude's a fucking. He does the math behind it, which is what leads him to these things. Which is kind of like, well, he did the math, and they're like, yeah, but he's probably wrong. I'm like, but he did the math. It doesn't lie. It doesn't matter what he says after that. You can call it a spaghetti monster. He did the math.
I
hard bit.
like Michio Kaku. He does a lot of good stuff from what I've
Yeah, he's
seen.
one of the best educational speakers I've seen.
By the way, guys,
he's so good.
sorry. Just because I couldn't read you like a fragment of the book, I just found like a recent Nature article talking about what I was saying about how people, like scientists, began thinking that the Big Crunch would be the most likely theory, and then slowly through the most recent measurements by the Planck telescope, whatever, they now think it's heat death. So like everything will decay. Yep.
Yeah, it's the main consensus of science. So it's still still not like
for sure. Yeah, for sure.
And that's where I tend to go too. But then I tend to go for informal cosmology, or I think, or whatever I was calling it. That is not mainstream science. That is like pretty much a theory of everything. I don't think it quite is, but it's close.
Grand unified, theory of everything. And to put it in, I mean, if we had an equation of a grand unified theory, like
cool.
we're not even ready for it. Like to have something that powerful.
Acceleration times time.
Sorry.
E equals mass times acceleration times time.
What is this?
That's my hypothesis of the grand unified theory of everything.
E equals.
I need to learn a lot more
equals
physics,
MAT.
Basically.
So E equals MAT. That's it.
Yes. Yeah.
Well, I don't. Yeah, I don't think that'll. I don't think that'll work. But
you should, probably go talk to someone. Maybe there's something behind that.
Yeah, we just found out what mass was, and so that was hard to figure that out. And
dude, I feel like we're super on Dunning-Kruger on the left side, and why something as simple as that probably is the answer. But we're looking for something more complex because we think that complexity equals the answer, and that's just simply not true.
I mean, we're trying to guess what it is, and you threw a rock in the bushes and said, well, I think they scream that shit's a squirrel. And I'm like, well, it could be a raccoon, man.
Wait. On another topic,
what I'm saying is that we've only done measurements based on the observable universe, and we've never even tried to utilize gravity as a reach out to make measurements on the cosmos as well.
No, we have.
Gravity breaks down on a subatomic level, which is where Einstein ran into his issue. See, the theory of relativity is E equals mc squared, specifically because of gravity. And so it wasn't until the Higgs boson or the Higgs field came along that we can understand why those things, we have mass, and so we can start diving in a quantum realm, but we're just not there yet. And so to think that space-time and the acceleration of space-time has a factor in it, I would say that
thinking that time came first.
What already has a factor in a grand unified theory, but that's so like that just won't work because they've already thought of that. I can guarantee you they've already thought of that. I mean, that's my own opinion, but that's my own opinion. But they already thought of that. That already is included in a lot of what they do. It's just not quite there yet. But if we had one equation,
I mean,
if You're breaking up, Desire. But if we had one equation, you can't even imagine the possibilities of what we could do with it. Like we would literally be able to be gods in this universe.
We could have true anime girls, man.
True anime girls, exactly. We would have 100%
cat girls.
Yeah, there would be no notice me senpai. It would just be.
Have you guys talked
I'm
about
into that.
LIGO and all that, and gravitational waves and all this shit? That's pretty cool.
Those things are badass, man. Created by black holes, if I remember right, and other
Yep.
large stars. Yeah, fucking
Yep.
amazing, dude. Yeah, and I think that's a hard thing to understand for me is the fact that all my cells are made of fucking atoms, are made of fucking, electrons, neutrons, and protons. But let's just say on the photon scale, right? All the photons in my body are being shifted just a little bit to the left and a little bit to the right, individually
everything
based on the
in general.
gravitational waves. I know, right?
Yeah, dude. It's also
What
like
the fuck?
it's incredible how
Crazy.
like measurement after measurement, like even like today the latest measurements, like they keep proving that Einstein was right. Like that motherfucker is still like proving things were right and new measurements were right. Like how crazy is that? And all this
Yeah,
like
it will continue. Math don't lie, man.
that guy, dude.
It does though. I'm back, but math does lie. Past 5 years, it does lie. So
I mean, in
never-
economics for sure, but like
Deniability.
this guy.
How did math hurt you? Show us on the doll where did math touch you?
Oh, just a left. If you're listening, please come back. Jack has done his research and would like to dispute your claim and can substantiate. But yes, guys, math is this amazing thing. But when it comes to modeling, it has a number of notable weaknesses. So, and the most famous form of mathematical modeling is statistics. And I don't know if you guys have ever heard the statement, lies, damn lies.
Yeah.
And
So deniability though, it lies. I think lies is the wrong term here. It can be it can be misapplied. It's the application of the mathematical findings is the thing that can is a problem. But the math itself is not lying if the math is sound.
Yeah, it's unbiased.
Yep.
So you can't say that there's a bias.
Yeah, it's just.
I mean,
it's not if the equation is correct, if it's demonstrable, then it's not a lie. But you can take a mathematical reality, let's say in statistics, and then have it inform you on something incorrectly. That can happen.
Sure. Yep.
Yeah, no, the specific saying I was mentioning refers to statistical inference.
Oh yeah, fuck man. Anytime human beings are so fucking bad at inference, and we think we're so good at it, but some of the smartest skeptics, some of the smartest people I know, make these bold ass inferences all the time. And I'm just like, slow the fuck down. Take an extra second to allow your skeptical foundation to manufacture your language in a way that doesn't make you sound like a tard.
You mean like a tardigrade?
I think you are.
Sorry, I had to do it.
Oh shit! Sorry.
My favorite animal.
Oh fuck.
But Travis, I think you are too hard on the sort of application of absolute skepticism, more specifically the lack thereof, for a number of reasons. But I don't want to get us too far off topic here. But maybe we should have an open mic on skepticism and its implications in the world. And all I'll say is this: is the founder of philosophical skepticism, René Descartes. He started off with radical disbelief. Even his radical disbelief was incomplete, and he acknowledged that it was not functionally possible in a complicated society of social animals.
Yeah. Skepticism being the mechanism of separating bullshit from reality. That's what my definition of skepticism is.
Wait, who was the founder of skepticism?
There is no founder of skepticism. The wise man of the village are the original skeptics, but they didn't call them that.
I thought it was Judah.
Fucking Judas.
René Descartes is often credited with it because he was the first person to put forward the the philosophy of radical disbelief.
Yeah.
Refusing anything to be true unless it was certainly true.
Yeah, so that and that isn't skepticism. It was something that people labeled like, oh, here is some foundational literature that skepticism this is how it came about and how it was being built. But it's more like I said, the simple human mechanism that we have of separating bullshit from reality is labeled as skepticism.
My favorite was Dawking's take. Is like, well, those people got eaten by the lion that chose not to believe it was there.
Right. Or and skepticism and the balance of skepticism and cynicism throughout history has been a little different based on the comfortability we find ourselves in and the survivability we find ourselves in. It plays a big role.
So
you would survive. You would be much. You would survive better as a cynic in very early primitive stages than you would as a skeptic. It's
a product of leisure, or that's a very profound thought.
Well, it's
the fact that we have an easier, more
moderation, please. Moderation, please. We're getting too far off topic, and
I agree.
This is something that's going to force me off topic as well. So let's get back to physics here.
It was profound. I thought that was amazing. That was very thought provoking, Pangburn, to say that we have the leisure to be in that direction. So sorry,
to be in what direction?
It's one of the most. It's one of the most, and I'll just finish this off with this, and we can get back on topic. But it's one of the most inspiring fundamental things about zoology and evolutionary biology that turns me on to it is that is the survival of species. What are the things that
wait
yeah hello
I'm not sure I understand what you're saying. What was thought provoking?
He's saying because
guys, we this is you're right to point out it's a really interesting topic, and we can go down this rabbit hole ad nauseum. That's why I'm putting an end to it now. So, Martin, did you come back to Grimm on his black hole universe destruction theory?
Prison style.
Why is it if you try to chime in there, we can't hear your mic? I see you're lighting up there.
Oh man, I was listening. Oh, sorry guys. Sorry, never mind.
I was just chuckling. Yeah, I had nothing to say.
Yeah, sorry. I was trying to find some tweet from Travis, and I was actually listening to to this through Twitter, and I was actually replying to that. I'm so sorry.
No worries. Okay, cool. So, back to physics. Any comebacks on infinite zero? Infinite zero. Theoretical zero.
Yeah. So, the problem of infinity isn't a problem unless you make it a problem. It's as far as I can tell, to claim that everything is finite is a mistake. It's just not a claim you have to make. You don't have to wear that hat. Based on my findings and the examining the evidence of what the pre-Big Bang state is, and I think if you think about things from a state of potential perspective, I'm convinced, and this is something I'm going to write a paper about and put it up for peer review. But I'm convinced that there's evidence sufficient to claim that there has always been a state of potential, and I think I just don't. And the level of certainty I would make that claim is of course, to escape the matrix hypothesis, I would make that claim to 99.9999% certainty. But that's how much I am convinced that there is an infinite, always has been, always will be state of potential, whether that's a state that Lawrence Krauss cares to call nothing. But, you know, I think there is something that exists that I call macro time, which would be an infinite scale of time, and you just kind of plot things on this infinite scale of time of where they happen to line up, and then micro time as we experience it in our Big Bang cosmos.
So
Travis, I would say that what I was describing earlier is exactly what you're describing. However, mine is a product of energy first and time later, where yours is a matter of time first and energy later.
I don't think you have to go there. I think I don't think you have to go to which one's before which. I think of it as snapshots in on a macro time scale.
But you need a change in the energy to get a different snapshot. The energy can maintain its position without changing, but then once you change it, you get a different snapshot, and that snapshot is what time is.
But I think what he's saying is that I think what Travis is saying is something always is and never not has been, and therefore if it ever was not has
and I'm
been,
saying that's
almost,
energy.
you can't have that. Yeah, but it doesn't matter what you call
I'm
it.
claiming that's energy.
Yeah.
He's claiming that's time.
So no, I'm not claiming it's time.
You said that there was an infinite time that you can plot things on.
Yeah, I'm saying micro or what I call macro time would be this infinite time scale, which seems kind of nonsensical to say, but I think that's just the reality of the prospect of something infinite seems very strange to us for whatever reason. But I think you can plot these instances in macro time on this scale. And it's not a matter of desired when we're talking about the infinite. It's not a matter of like which one is before which, because I think within this model you could probably claim that energy would be as infinite as time in this.
True.
No, I'm saying that time generates the energy.
But the opposite Pangburn, the opposite
the time.
The opposite Pangburn would be unfathomable. So I would have to unfortunately agree with you, even though I haven't gone through that thought process. But looking at the opposite of non-existence would be unfathomable. So therefore, I kind of have to be contentious.
Yeah, and that's what and that's what I'm trying to do. Basically, is for lack of a better term, is bend everyone's mind over and say you're going to take this dick of language.
You're describing E equals MC squared. You're saying no different than Einstein or Newton or anybody else.
No,
you're describing exactly what's already described.
No.
Once again, I want what you're smoking. I want it. I want an ounce of it. I don't know what it's going to cost me, but I need a little bit of whatever you're dosing, dude.
Wait. I'm going to disallow comments like that. I'm
going to make deniability take it and watch.
Am I muted?
I like Desired. Desired, are we not good friends? Come on, I like Desired. He's good.
I know. I'm not
faith.
sure if anybody's responding to me or not.
I wish I had Desired energy.
So what I thought, the reason I went to get Desired in there after Travis spoke is when we had the time to fully explore his thought experiments, correct me if I'm wrong, Desired, I got an impression that he was saying that matter or energy or whatever, when it's static and is not moving, there is no time scale. As soon as it moves, it creates a time scale.
Yeah.
So without that,
there's no evidence of that.
Without that state of potential.
How is there no evidence?
I mean,
here's the point. Count time.
Can you do it in a?
We use quartz vibrations, count time. We count seconds by the number of
that's micro
flips of an electron.
That's micro time.
Yes, all of that adds up.
That's
hold on. Pause. Let's just frame this. Travis, maybe if you could go into more detail on micro time.
Yeah, so
macro time.
Micro time is the time of how we measure time here, and how, the time of Einstein's relativity. That's micro time. What Desired is describing. Macro time is actually, because I can imagine at some point everything in a macro time sense, everything ceasing to move, energy ceasing to be here. And maybe, and this is why this is why I don't think people like Desired should be making claims like, you have to have X in order to have time. I don't think you need to make that claim. I think you can say.
But you're saying that you have to have time to have energy. So you're just making the same argument from a different angle, correct?
Well,
or am I misunderstanding what you're saying?
Well, what I'm saying about time, and this is why I think as soon as you start adding baggage to these claims, there's just a lot more evidence that has to come forward, and then this is why I take making a claim about this macro time existing infinitely very, very seriously, and then when things start getting stacked or added onto that, I'm like, okay, this is a whole nother theory, a whole nother can of worms altogether.
Right, and my theory doesn't allow for a can of worms. It goes straight through all the way up.
But you have to do it. Hey, you have to do it.
So hold on, guys. I think we're still talking past each other.
Can I chime in?
I experience this a lot with when I'm trying to explain business to people that don't understand business. I'm using jargon and concepts that I take for granted as self-evident, and it often confuses the receiver thereof. So I'm saying this purely because I know nothing about physics in depth, and I'm still confused about Travis's differentiation between micro time and macro time.
Let me.
I got it.
Yeah, I think Grimm's got it, but let me make it a little more. So deniability, we are, the things that we use to measure time in science, like Einstein's theory of relativity, and how time is relative. Desired left. But essentially, time based on Big Bang time, the same way that we measure the time all the way back to when the Big Bang occurred.
Right before.
Yes. So right before. This is what I would call micro time. But even our own micro time in our cosmos falls into somewhere on the scale of infinite macro time. The time of all of everything that's ever been ever. It just, and I would call it the state of potential, like the full on, and think of an infinite line deniability, an infinite line being that you could go back 17 quadrillion years in micro time, and you would find a state of potential there. On this macro time scale, but our micro time scale wouldn't exist.
Cool. It's funny. So. It's funny though that you call it state of potential, because as far as and that you also said that it would always be there, and it always has been, because if by our latest measurements, if we're right, then the end of the universe would be like maximum, like the biggest amount of entropy possible, so like no potential, just like complete disorder.
Well, actually disorder is still a state of potential, Martin. This is the point of why I think this is the key to this unifying theory, because I know the scientist in all of us wants to find a place in which there would be no state of potential, but in all of my searching, even in my imagination, even in the matrix hypothesis of simulation theory, even the simulator, the matrix controller cannot escape this. Even a god omniscient God cannot escape this state of potential equation, because even a God would be sitting in a state of potential even if he denied it.
It makes sense to me because of the fact that the opposite of what he's talking about is unfathomable. Can you not imagine no space, no time, no universe?
That's
no,
what I'm describing when I say energy. That is specifically what I'm saying when I say a blanket of energy at pure uniformity.
But that still is something, and so therefore,
right.
it must
exist. You can't exist it not.
Hold on.
Sorry.
First off,
Grim refine, and then desired. You can go after that.
Sure. First off, desired. You need to speak in a Dinesh D'Souza accent, so that needs to happen. And number two,
that sounded awfully attacking. Are you trying to say that my ideas are not good?
I'm just saying. It's a fun jab. Just everyone relax.
Okay.
What I really mean by that is that your articulation of the idea takes a few explanations, but I do like the fact that you approach it from a different standpoint. But what I'm trying to say is what Pangburn is basically raping you with the fact that something is existing, and even though you can call it whatever you want, we can call it our current space-time, pre-Big Bang, after Big Bang, after the fucking universe closes up into a snail shell, doesn't even matter. You can still account on that on a time scale, just like you can account pre-humans, before humans, and all that. There's all these time scales. Micro would be what happens with humans. Macro would be life on the planet. Same as the universe or beyond the universe, there's still a macro time scale, even if the universe is part of a micro
So all he's
position.
done is taken the prime mover and move it up to us.
He has the ultimate theory of the fact that the only other way to say that the only other way to say that it doesn't exist.
Two separate things and isn't unified. He's got two definitions for two different things: a macro and a micro. And all macro is, like we tell everybody who says evolution doesn't work, all macro is a collection of micro, which means that macro is micro. It is the same thing. So trying to delineate
micro,
between them is no different than calling it God.
Just let me add a piece of clarification. Micro still fits on the macro timescale. Micro just exists in the sense of how we relate with our time in our own universe that was created by the Big Bang. That's why the micro concept.
Anything that describes that doesn't tend to describe the quantum, and that's the problem.
No,
that's because we put time before
desired,
and somehow try to get matter out of it.
Desired.
Right?
No,
the state of potential theory that will be in my second book is talking about states of potential and everything that exists within those states.
That's what I'm saying. What you're saying, what you're describing is change in things, not time or energy.
No.
Can I jump in for a second?
Yeah, Martin.
It's change.
Can I still, sorry, Pangburn. Maybe I'm missing something. I just still don't understand how, complete, at least in a global, time frame, complete entropy, maximum entropy is still a state of potential when maximum entropy literally means no change can happen. Well, you cannot descend into
so Martin, if we reach maximal entropy, what do our current predictions tell us?
That nothing, everything. I don't know how to say it.
Quantum fluctuations still happen.
Sure. Yeah.
So my point is that
random?
So no, there is no random. Random is a word that everyone who's interested in physics should get out of their head.
Okay. So what are you describing when you're saying that? What are these fluctuations?
Pre-Big Bang. Quantum fluctuations will be quantum fluctuations that are popping in and out of existence
by a prescribed method.
But that doesn't change the fact that entropy
doesn't matter.
Still go up.
That can be mathematically predicted.
We can.
None of that matters.
Wait.
Yes, it does. Specifically.
Wait a second.
Yes,
wait a second. Desire.
Just
wait. Desire.
First of all, desired. Just chill out. You're yelling into the mic, and it's
I'm so sorry. I'm not trying to. I'm on a headphone that I'm not normally on.
Yeah, you don't have to yell. We can hear you clear. But
Yeah.
Okay.
Martin, go ahead.
Sorry.
Yeah, I was just saying, like, yes, you're absolutely true. In a vacuum, still, like, quantum fluctuations would still happen, but that doesn't, like, for a brief period of time, but that doesn't mean that entropy will not keep, like, going maximum.
Right.
Yes, for a little bit, there will be a quantum fluctuation, but it will still go to maximum entropy and go back to, like, no possible potential order.
So that, when you say no possible potential, that is why I am creating this theory, and that spot right there, Martin, I am saying cannot exist.
I agree.
I guess I didn't explain myself properly.
I'm coming
Like,
at
of
it from
course,
a different angle.
quantum fluctuations would still happen, but in the end, that doesn't change that the entropy is going to more.
That would be the end of his timeline.
Yeah. So Martin, what you're describing is something that would interrupt the infinite macro timescale, and I'm just saying I don't think that exists.
I don't think.
Right.
Yeah.
I think it's unfathomable.
Yeah, I don't understand how an
I'm not
infinite
sure.
can happen.
I'm not sure if that would be the case.
Like,
I'm not sure if that
you're
would be the
saying
case that it would
something can
end.
exist inside of a jar so long as it's outside of a jar. Like, there
Wait,
is
wait,
no
wait.
such thing as infinite time.
Wait,
Like,
I'm
time
just
can't generate itself. Or time doesn't.
Desired. You are making. I suggest you speak in terms of, instead of being so self-righteous and absolute about the claims you're making, I would speak in terms of, like, it doesn't seem to.
What yours are.
You may say, I think it's more sound to say, it doesn't seem like time can be infinite to you for these reasons. But if you're kind of like, the way you're describing this and the way you're talking about it, it's just, if you make some self-righteous absolutist claim, you're going to have to demonstrate it, right?
I have a question that might clear this up. Have you said pre-Big Bang time?
Pre-Big Bang time would fall in the macro scale of time.
Which would mean that if there can't be anything before Big Bang, then time is not infinite.
But we don't know that, though.
Yeah,
we don't know that, so
that doesn't matter.
The same conversation say both things.
Desired. The reason why.
Put them in one hypothesis.
Let me explain this. The reason why the state of potential works, regardless of what that macro time is, it's basically saying that regardless of what is going on, there will always be a state of potential, because there has been a state of potential. It's not it.
Yeah, that's rough, but I see where you're coming from now. That
So
makes
it's
sense.
like so here's an easy way. Desired. What do you just give me on a hypothesis of what do you think happened before Big Bang?
Energy existed in a blanket of uniformity.
Okay, so there's an energy, a blanket existing in uniformity. That is a portion that happened before the Big Bang
and that's a state of potential.
Yep.
So we're saying the same thing, and you're looking at it from human, and I'm looking at it from quantum.
No.
Well, you're looking at it from a hypothesis.
Desired.
Desired. So is he.
Desired.
Right?
It doesn't matter what you call all the stuff inside the state of potential. It's still a state of potential.
You could say that God was jerking it before the Big Bang, and that would still be on the macro scale.
But Desire, you are taking the leap to say, oh, this is what I think the state is. I'm not saying that. I'm saying the state is there. I'm not saying what's in that snapshot, that state. Cool. But you're trying to make a claim of what is there. You're going to have to demonstrate why you think it's this blanket of energy. What I'm saying is it's a state of potential where something can happen.
And mass exists.
Oh God.
I mean, I do agree. If we're here, then in the past we always had the potential for sure. But I'm not sure that you can claim in the near future. In the end.
Moderation, please. We're going around in semantic circles. Datsu, you want to chime in there?
I basically wanted to try to say what Pangburn was in a different way, but I think it's understood all the way around. I don't think.
Yeah, I to be honest, I think we're going around in semantic circles, which is understandable, because nobody in this room, maybe bar Martin and Grimm and Pangburn, are studied physics people. So
It's actually
I
a
think,
philosophy question, which is or philosophy.
It is. It hasn't gotten into physics yet.
Yeah, it hasn't even touched on physics, which is kind of crazy.
Well, it's
Yeah,
and this is
using
interesting.
terms of physics like the quantum and timescales and all that.
Yeah.
So I still think we're going on.
But deniability.
Here.
One thing I do want to say
Good
about
paradox.
this is that I think this uniform theory will have a mix of art and science, and I always have thought that. And,
I think it has everything.
And well, yeah, but I think art and science actually handles
psychology.
everything. Yeah.
It's
I
interesting.
guess, sure.
Yeah.
I think
But
it's funny
that-
because. Go ahead.
Go ahead.
I was going to say, but Pangburn, the only other question would be, yes, but have you thought of nothingness?
For fuck's sake.
Let me try really hard.
Well, the funny thing is
Fuck!
absolute nothingness, and this is what Krauss has been trying to describe, but he went in his book with this term nothing, which I think is just a fucking mistake. It's just, I think it's like a kind of a Hollywood-like approach to kind of confuse people. It's not nothing. It's a whole lot of something going on when we start thinking about pre-Big Bang states and states outside of what I would call micro time. But
yeah,
regardless of this,
super
I'm gonna love to hear what Lawrence has to say about the state of potential once at the end of the universe and all this.
Yeah, well, once I publish my book, it's like I actually have been working a lot more on my second book than my first book right now, and it kind of is maybe telling me that I might be publishing my second book before my first. But I'm very excited for it. It's going to include a mathematical, very short, small mathematical equation that I think explains the state of potential. And I think much to everyone's disgust and dismay, it's not going to give everyone access to all of this amazing information that everyone dreamed of. I don't think the unifying theory is going to do that.
All right, but you're gonna ask him about this, right? Or you're gonna talk about this tomorrow?
Oh no! I'm talking about when my second book comes out and people start critiquing it. I'll be.
Oh yeah, for sure.
Lawrence will probably write the foreword for it. So.
Nice.
Does anybody else have this sensation that nothingness is palatable? Like I just feel like I can taste nothing.
Well, it's because you're finite, Wise. I think us being finite beings, nothingness is all part of the living experience, the life experience. This is all finite, and brain death is death.
And I can't imagine nothingness, nor can I. It's unfathomable, and I challenge anybody to do it. And that's really the crux of Pangburn's thought experience of like, well, I can put everything on a macro time scale because I can't prove that nothing exists, but I can definitely prove something exists. Therefore, I can Occam's razor the rest of that shit.
Right.
Well, I can't really fathom nothingness either, but it
but you
might
guys,
be the art side of it.
I'm saying.
Like,
sorry.
No, go ahead.
I'm saying imagine nothingness within your dead parent or your dead relative or your dead whoever. They are now nothing in the life sense. So I think we can understand nothing on that scale. But this idea of absolute nothing, it seems like the more we understand about particle physics, shows us that this isn't. This is a fantasy, much like God's.
So I have a question.
I have a.
Take this in a different direction here.
This is fucking awesome, by the way.
Before we go somewhere else, can I make an argument against nothingness? Like a philosophical argument? So if you have nothing, and if you were to have nothing, you can't have something also at any point in time ever, or else that nothing would be basically kind of pushed out of the way by that something.
Yeah.
So
yeah. This is why absolute nothing it can exist. The state of it can be absolutely nothing with a state of potential, but the state of potential is something.
it could be absolutely nothing if nothing ever existed ever. But as soon as something exists, then nothing never existed.
But you said, Dal, you're saying that if there was nothing ever.
Yeah,
I don't.
Exactly.
I just I think. Yeah, I mean, it just sounds like fantasy and myth to me. This idea of no state of potential. It's just like not even the mythical gods can escape that.
Actually, Dastu's point helped me a lot to understand. That was pretty good.
Yes, because what I'm trying to say is that if something does exist, it means nothing never existed. Because something had. Yeah.
Although, like the difference between nothing, absolute nothing, and just like a couple quantum particles popping in and out of existence, the difference is pretty minimal.
Huge. I think it's huge.
So I've got two questions now. One is on quantum particles popping in and out of nothing, and does that not violate Einstein's theory that energy cannot be destroyed? And perhaps maybe our understanding is just insufficient to the point that it's not really popping in and out of existence. It's popping from this existence to another existence in time and space, and then back again.
Ooh, I want to take this. So
my question on that.
Wait. Can Grim answer? Can Grim answer?
Yes,
please. So Einstein actually kind of predicted some of these, if I remember right, and that is quantum tunneling, and that's the fact that you'll have particles that can be in one part of space-time and then immediately shoot to another part of space-time. So his math was actually on the verge of coming across this before his death, which was where he was headed for grand unified theory. And
but that's different to quantum fluctuations, though.
It is, but he was touching around these, so it actually does kind of include it. And then now we have these fucking supercomputers that are able to actually be working off of that theory.
So, and just a quick, just to give it just a quick bare bones, in quantum physics, a quantum fluctuation or vacuum state fluctuation or vacuum fluctuation is the temporary random change in the amount of energy in a point in space, as prescribed by Heisenberg's uncertainty principle.
Yeah, the temporary random change was my point. That even it's just temporary.
Right, and I think
what does that mean? So does that mean that it's predictable, or that is something that is unpredictable?
I think.
What does that random mean? Because you had mentioned earlier, people getting into physics shouldn't use random. So when it's used in a definition, that makes it a little different.
Every single time a physicist uses random, I can just bend them over on it, because I say, why do you think it's random? Well, I don't know. It just pops there. I don't know. It's like
I don't know.
It's like an argument from ignorance.
It means I don't know and you don't know.
No, every time I've heard it explained is that the math points to uncertainty.
Yeah.
Not that we don't know. It points to the fact that you can't know.
Yeah.
That's a pretty good point, though. That's a good point.
Yeah, it's not.
It is not predictable.
That's Sean Carroll.
Yeah. So because something seems to point to uncertainty does not mean that that's what it is. That's the main point.
You run into the fallacy of saying that there are things that can never be known.
Right.
And that's a
fallacy.
Well,
so all things can be known. Always.
Well, no one made that
proof
claim.
that continues to be so.
Yeah, but I wouldn't. I'm not.
Question I was asking, right? Like, for all intents and purposes, this electron that's disappearing, as we described now, out of existence in what we're observing in front of us, it could be reappearing in our same universe 300 million light years away, and then popping back to where we're observing.
So deniability.
No way for us to measure that.
Yeah. So and this is where our language meets very new age scientific understanding in the particle physics realm. Sometimes we fail to describe things properly, and then we learn more through conversation, things like that. Just like Lawrence Krauss's idea, using nothing to describe pre-Big Bang state. It's not. We're not going to see people using that anymore, at least for much longer.
And this touches on Higgs boson. So the way that it creates mass and then takes away
Right.
mass, is exactly why we found the Higgs particle being so just important to us understanding physics. And because of that, we're able to look at photons and go, how the fuck is this thing losing mass, gaining mass, losing mass? And it's random. And the word random is simply because we don't know yet.
Yeah.
And I would say, to Deniability's question, I have somewhat of an answer. No, I cannot say that everything. I cannot say that everything will never be known, but I can say that we have a long track record of always finding out the variables.
Right.
I'm so confused because you guys keep saying to not use random, and then you keep saying random.
Yeah,
but then you're defining it as something different than what every physicist I've ever listened to would describe it as.
Yes.
Just because it is random doesn't mean you can't know that it's random.
Desired.
Sorry for the random
Right?
answer.
Yeah, it's not. It's random being used in the physics language of explaining this. What they should be saying is seemingly random or seems random. It's not anyone.
But I
If
thought
they're
the
gonna
math specifically pointed to unpredictability.
Unknown pattern.
No, it's an unknown. Yeah, it's not. If it points to uncertainty, and this is where like Krauss will. This is where skeptics can come in and to an expert who or is delivering a lecture and they say, well, and this is this, and then the skeptic can put up his hand and say, well, how do you know that that's that? Well, it just seems that way based on the evidence. It's like, well, don't make that absolutist claim then. Say that. And I've talked to many physicists, theoretical physicists, who do make these make the mistake of making these absolutist claims. And I just wanted to touch on something about the Higgs particle. Lawrence, and this is how new age this stuff is. Lawrence Krauss was convinced that this Higgs particle would not be found. It would not be detected.
Oh no shit.
And
Really?
and it was.
Yes, like I don't understand why people think we're so advanced.
Well, I mean, we're a very special
Can I read
age.
something from what?
Go against
Can I read
very
something about
basic
quantum
fundamental
fluctuations?
discovery.
Yeah, Martin, I want to hear what you got to read there.
It's literally going further because I literally had the same page open. That just literally Googled quantum fluctuations. What you were reading.
Yeah.
So I click on the Wikipedia page, and it talks a bit about what the deniability was talking about. It seemingly violates the conservation of energy, right?
Right.
So here it says that since these particles are created spontaneously without a source of energy, vacuum fluctuations of virtual particles violate conservation of energy. Yes. However, this is allowed because they annihilate each other within the time limit set by the uncertainty principle, and so are not observable. And then it explains a bit more. But that's pretty cool.
Yes,
that's pretty crazy.
It is mind-boggling that we are able to
That
even.
makes perfect sense.
Yeah, it's mind-boggling.
That makes perfect sense to me. That is exactly
no,
what I'm talking about.
it
is
makes
trying to
sense.
turn my energy
Yeah.
field.
It makes sense, but it's
That
also
is
pretty
what
crazy.
happens. Just like it appears at different points along the timeline, it happens to appear in the energy field, and that is the prime mover.
Well, I think
That's
This all
what
takes
I'm
me
saying.
back to a quote that I think is very true about quantum physics. If anyone claims to fully understand quantum physics, then won't fully
Right.
understand quantum
Yes,
physics.
others
Yes, we
humans
said
calling
this.
other
I know
humans
this.
idiots. Got it.
Who said this?
We all
I
are
forgot.
calling each
I've
other-
heard this before.
It's Feynman, I
I
think.
don't know. Yeah.
Feynman, yeah.
So I think we're starting to
But
go
that's
around
also the man who
circles
got
again,
most of
yeah?
his education on his own. So
So I wanted to ask the second question I wanted to ask. It goes back to this micro and macro time. I get that we have some theories about that, and they seem to make logical sense. But for the moment, it's a theory. Let's hypothesize that we got sufficiently technologically advanced to actually prove what was behind the Iron Curtain, as it were. Would it actually make a difference to anything?
So this is, I'm going to outline this in book 2, but unfortunately, I don't think this great unveiling of amazing things that will be derived from this unifying theory, it's going to be a letdown. It's going to be more simplistic than I think we've. If we look at the poor bastards wrestling with string theory, trying to, use advanced math and these and trying to their best to unite what I describe as these these dimensional mailboxes. I just think it's I think the real answer is much more simple than that. And the someone mentioned the Dunning-Kruger effect, and there I think what the problem is too is that where abstract thinking and imagination, like Einstein, allowed that to dictate his way. I think that's what's been needed here, and some of that has maybe been stifled by focusing too much on certain aspects or certain particles, or looking for the certain missing ingredient instead of a greater description that might unify everything.
So
Yeah, I think.
Nice.
Sorry.
Noise.
Yeah. Well, let me refine it to a better question then, I think. Why do we need a grand unifying theory? For what purpose does it serve?
We need to understand.
It would lead to understanding and lead to advancements in technology quite significantly, because we would actually understand how energy transfers through objects more sufficiently. It would allow us to store energy better. It would also allow us to understand how to move energy more efficiently and allow faster compute.
But
Sure, I mean, I think essentially, I think essentially is when you know things and you have different theories for different stuff, but you cannot unify them. It pretty much means that you don't have a real, like, the ultimate, as ultimate as you can get, of course, and an appropriate understanding of those things. And when you manage to unify them, that means that you've at least managed to understand them in a global frame of reference. So the fact that we cannot unify our physics means that we need to do better.
I think me and Pangburn have.
I'm thinking
Yeah.
more
And we're using different explanations, but we're saying generally the same thing.
Yeah.
I hope I see you in the Nobel Prize next year, man.
It'll take longer than a year.
Well,
But I think we're saying very similar things, and he's pretty much right.
Look, if I haven't misunderstood the micro time versus macro time thing, it seems to me that functionally we just needed a theoretical understanding of micro time, because an understanding of macro time has no functional purpose in how we interact with the universe. Would that be accurate?
No, I think I actually think it's hard to it's hard because when I think about the human experience and what these discoveries might do for us, by the time, and you're kind of right, deniability, the time that it takes for us to engage with something like macro time in any real way. Let's think of it this way. One thing that it may do, as long as we can download our what's been formerly known as consciousness, but download whatever the emergent properties of our mind are into software form and send them out on radio waves and exist in creating our own little software universes for ourselves. We need to escape the inevitable death of our own micro time. So the question will be
Travis.
I don't think we will.
Just one one sec,
Yeah.
Skeptic.
I got a question when you.
Yeah. So that will be the ultimate pursuit of once we're able to download ourselves into, existing in a light beam, creating our own cosmoses, whatever we want to do, just like we're game creators, the Matrix creators. We're going to want to figure out a fucking way to exist outside of our own micro, nearly guaranteed heat death or whatever death. So how do we breach the event horizon? How do we get on that macro time scale outside of our own micro time scale? And I think that is an important pursuit, but well, I guess I'll leave it there.
That was pretty well put, man.
I got a question.
Anyways, I just wanted to thank everyone before I go to bed.
Thanks.
In order, Skeptic has a question, and then Martin can go
Martin was just saying goodbye, so thanks, Martin.
Okay. Bye, Martin.
No problem.
I got a question. I don't understand what you're talking about, really. I experienced
Travis, I
time
agree
as
with you.
Just one sec,
sequence of
Wise.
events.
Skeptic's going.
Sure. Go ahead.
Time is a sequence of events happening at a constant. So I don't know what you're saying by micro time versus macro time.
Yeah, it's a new.
I don't know. I really don't know what that you're.
Yeah, it's a new concept that'll be part of my second book. But basically, micro time being the time we all know, the time that you're talking about, Skeptic. The addition being macro time has to do with my state of potential theory. That is going to claim that there has always been a state of potential. And that means that always being a state of potential means that there has always been a state of potential, which means there has always been a state of potential. This is it's an infinite line of time or potential things to occur. So this, you have to think about micro time being the time that we are familiar with, the time of Einstein, but the macro time being the time of what I would say is the infinite outside time scale, where our micro timeline still is applied to this macro timeline, but we are not outside our micro timeline. This macro timeline, within it exists the infinite amount of states of potential that have ever been and ever will be.
So, Travis, I have a question. In time, where do we get mass from, or energy, or anything that exists inside of time?
I don't know.
Okay.
I'm not willing to make that claim, and I'm not willing to make that claim.
I think that I agree. That's perfect. I agree with that. That's a solid place to stand. And what I'm saying is that just sounds like time exists, and I don't see much past that. I think what you're trying to do with it, I agree with, and point out that it is infinite, but nothing physically comes out of time. However, we only count time through physical actions, right? Every time a quartz crystal vibrates, we use so many vibrations to count a second. Whenever anything happens, that's every calculation our brain makes is how we tell the difference of time going through it. So you cannot have time without matter existing. They are inextricably linked. And all you're describing is just one portion of it without including an absolute must-have portion connected to it.
Yeah, I don't think.
I disagree.
Yeah, there isn't an absolute required. And again, Desired, you're wanting to add claims, and feel free to do so. But and you might say your theory isn't describing X. Well, it's not meant to describe X. It's meant to simply.
That's what I'm trying to understand.
Right.
Because if
sorry, Grim.
Yeah. Sorry, I was just going to say, because if before the Big Bang happened, it was just God jerking it, and we never called that energy, would still fit on a macro time scale of Pangburn of what he's talking about.
Right.
Right. So what's it describing in the end?
Or the beginning.
So
or in between.
What is it describing?
So it's describing that everything
time exists.
desired. It's describing that
He got you.
That that everything is a state of potential, and
it's a
right. But you're saying that everything that exists is a state of potential, but you're not giving a place for that thing to exist in. You're only saying time.
No, I did give it. I did give it.
That.
State is a place.
State. Okay. Mm-hmm. And then potential is time.
Potential is that something is happening.
Potential is the potential for something to be.
Yes. Right. So the energy or the mass or the state, the thing exists, and then the time comes out of it, is what you're saying.
No, I'm saying that everything.
Time is
because if you're talking about solely time, then you don't need a thing.
So here's where
I'm losing something.
And I have the greatest sympathy for you because I'm getting tripped up on the same thing. And I think where Desired's getting tripped up is from his understanding, which I think is fair. Time only exists as a description of change, and absent change, he's saying there's no time. So I think what he's trying to get at is if you're not describing change, why are you using the word time
because
in macro
deniability,
time?
I'm not willing to make that claim because I can imagine on this infinite macro scale some event occurring where the state of potential freezes.
So you're saying absence of anything is potential?
I just wanted to point out
for
that
something,
I couldn't hear
right?
Skeptic talking.
Oh, yeah, you might have him muted, and he was just talking again. But Skeptic, go ahead.
Yeah.
So you're saying the absence of anything is potential for everything?
No.
It's
just it's there is a. I think with this there's an urge to want to reform the claim and to add something to it, or to it simply is that there has always been a state of potential, and then what you have to do is understand what state of potential means, and that's what my book will do. But in short form, state of potential, it just means you can take a snapshot of what is in that moment, in a microsecond, you can take a state of potential in that moment and say, we have a state of potential.
Time is a result. It is a byfactor of what we're witnessing or anything witnessing. So Pangburn in himself is calling himself a god. He's able to step outside of the universe and say, there's the universe, here's what happened before the universe, here's what's going to happen behind the universe. Put that on a time scale, and that's all he's saying. And to imagine anything that is not on that time scale is unfathomably possible, like impossible. It's just, you cannot imagine nothing. You can't do it. So that's the opposite outside of the time scale.
Can I speak to some of that?
Yeah.
As far as imagining macro time and stuff, I think what we might need to incorporate is a meditative quality of mind to grasp some of these concepts, and I'm not really sure what that means. I've been practicing my meditation with Sam Harris, and it seems like
it's interesting that you bring that up, Wise, and the reason why is because when people who have spent their life's work even writing and talking about theory of everything, there is a lot of anxiety towards things that seem to be oversimplifications on the surface, and you get a lot of nonsensical questioning and knee-jerk emotional reaction to simplicity, I think, in very complicated fields, which I think is I think if people and this is why the book was, if I didn't think the book was necessary, I would just put out a video or draw a picture. But I think the book is necessary to bring people to this, to what I think is a simplistic realization of this unification. But yeah.
Oh yeah, and just to add one more thing, when he asks to leave your mind wide open, not to try anything, my mind like does this weird. It might envision storks, like all this chatter in my head when I'm just not trying to do anything, but just I keep the mind wide open. I've no. Well, I mean, I could try to put some descriptive language to that, but it's just weird what the mind comes up with when you relinquish control.
Yeah.
I think, Travis, I can sum up what you're saying with Google. Like, if you look at what Google is capable of, like all of the things that just the website Google, you can get to by going, like starting there, that simple little bit of code that's not very long in the grand scheme of what you can accomplish by going through Google, it doesn't take a lot of code to get you a near infinite amount of information.
Yeah, I that's a really interesting analogy.
And that's what I define as consciousness. That's what I would define as consciousness. That bit of code allows for that expansion, or well, I would call it sentience because I have a little bit of a different definition for consciousness with my hypothesis. But what you guys are calling consciousness and what I would call sentience comes from that. If that makes sense. Hello? Oh,
What do you guys?
my phone cut out again.
No, I heard you anyway.
I heard
just mic dropped everyone in silence.
That's what I was worried about.
I just have a question for you, Deniability. How do you, like, it seems like you have a theory. Like, is it just because you think about these things? Like, I don't really have a theory on anything.
I think you meant desired wise.
Oh yeah.
No, I think he's talking about. Oh, me? Yes, I have a hypothesis. I wouldn't call it a theory. I haven't taken physics enough yet.
Oh, okay. So is this something like you're working on? Like, because I've
been working on it for about 2 months.
Oh wow.
Yeah.
Okay. How do you guys feel about Stephen Wolfram?
I like Stephen Wolfram.
Hey,
I think he's close.
Deniability. I'm gonna pull things off the air, but I just wanted to give a shout out to you guys. I'll be awarding some points today for everyone's discourse. It was really really awesome. I love these conversations. Next week we'll be sure to wrestle with the wonders of biology. I want to do
that. I'm not the worst.
I want to do some more science-driven topics because I do love them. They're the ones I'm most interested in. So
I wonder if Robin
thank
will
you
show
guys
up for that one.
Thank you very much for the platform.
Yeah.
Pangburn. We really appreciate it.
Guys, and I hope you guys subscribe through the website, pang-burn.com/subscription. Lawrence Krauss tomorrow. Don't miss the opportunity. 5 p.m. Pacific, we will be Q&Aing with Lawrence Krauss. Thanks, guys.
Yeah, if I subscribe tonight, I'll still get to ask a question, right?
Of course. You'll be on board for all of our future Q&As with future intellectuals as well. So, all right, guys. Thank you. Thank you, Deniability.
Cool.
Excellent job, Deniability.
All right. Thanks, everyone who tuned in. I will be uploading this on YouTube. For those of you on YouTube, make sure you subscribe, hit the notification bell. And, please subscribe on our website, pang-burn.com/subscription. We're doing these Q&As now with famous intellectuals and authors. which I'm really looking forward to. So, it's an opportunity for you guys to interact. Lawrence Krauss is tomorrow. That's November 25th, 2020, 5 p.m. Pacific. Thank you guys so much. And as always, let art and science inspire.